Hello, mic testing 1 2 3. Hello, hello.
Hello. Hello. Mic test. Mic test. Hello. Mic test. Mic testing one. Hello. Mic. अच्छे से बोल रहे. Hello. Hello. Mic testing. आवाज येतोय? Yes, you are audible.
Hello. Hello? Hello?
नमस्ते सर जी। Good morning, everyone. Is everything okay? Sanskriti, yourself, and then that all the participants are able to share their screen and everything.
Can you repeat, sir?
I said check that all the participants. Okay, we have 8 projects in this session, right?
Yes, sir.
Yeah. Check that they can share their screen or not properly.
Okay, sir.
Yeah, their presentation is we are able to see it or not properly. That we have to check right now, because once we go live, that will be difficult then.
Okay, sir, I'll do it.
Nitish, everything is okay? Okay. Our guest of honor has joined. Brenda sir has joined already. Yeah. Rekha madam, everything okay?
Yes, sir. Sir, can you hear me?
Yes, ma'am. Yes, ma'am. Okay.
Hello.
Yes, ma'am. Yes,
Sir,
ma'am.
audible?
Yes,
Okay.
ma'am.
Okay, sir.
Yeah.
Hello.
Yes, Jitendra sir. Bola.
Good morning, sir.
Good morning.
Yeah. So I think our order, whatever we have discussed, order yesterday night, that is, I think, no change in that order, na, sir?
Yeah, there is no change.
Okay. Sir, I think we should also inform right now before going live to all the participants that there has to be at least one backup ready to every participant, because if any problem happens, like network issue or MSCB problem or light burn problem like that, then there has to be another team member who is ready with the same page of the presentation. So there has to be one backup ready with the every team. I think that we have to inform to all participants.
Yes, sir. I hope all participants are listening.
Yeah. Okay, so execution team, can you put this message in the chat also, because there might be some participants who will be joining after 9:45, because we have given some time like 9:30 and 9:45. So you can post this again whenever means like people joins in. Yeah, yeah. On WhatsApp group also you put the message, and this chat group chat also you put the message.
Good morning.
Morning, sir.
Good morning, sir. Good morning.
Sir, Ukarande sir has already joined. He is with us. So everything is okay. Nitish, we are live. We are on right track. Live. Nitish, are on live, no? Are we live right now? Okay, just see that it is okay working. So we can start. Okay. Ukranda sir, shall we start, sir?
Yes.
Okay. Okay. Thank you, sir. Others will keep themselves mute. Okay. Rekha ma'am, please unmute yourself and then start. Okay. Nikshit, Nitish, sorry. Take care that we are being live properly. Okay. Yeah. Sanskriti, ready. Let's go then.
Yes, sir. Good morning, everyone. A competition makes one strive to do better. The contest challenges students to show their understanding of the basic principles through problem solving and such great skills. It trains to seek out challenges and to endure setbacks. The Engineering Mathematics Teachers Society, India, EMTSI, in collaboration with CM e-learning presents Engineering Mathematics Application Project Competition e-MAPCO 2020 online. Professors and dear students, a very good morning. On behalf of the organizing team of today's event, I take this opportunity to welcome one and all on this auspicious occasion. Now I would request to Dr. Jangam Shaw, who will brief about the EMTSI.
Hello, good morning all, the respected Dayas and my friends. Okay, so the Association of Engineering Mathematics Teacher started in the year of 1996. Since the year of 1996, we organized many other programs. We organized the programs like teachers training. We organize the programs like workshops and many more. So this year we are organized this competition, engineering mathematics project competition 2020. So this year we are first time organizing this competition online mode, as we know the reason. Okay, so here we have got many entries from all the most of the states in India, ranging from like we got the entries from Chennai, we got entries from Gujarat, and we got the entries from other states also. Okay, so this was a very good thing that we were able to reach in many states. Okay. So we wish all the best to the participants, and we hope you enjoy this competition. Thank you, Rekha ma'am.
Thank you, sir, for the introduction. Now I would like to request Rekha ma'am to give a brief introduction about the judges.
Very good morning to all. Respected guest of honor, Dr. S.K. Ukrande, dignitaries, faculties, members of Engineering Mathematics Teachers Society, India, and dear students. It's my privilege to extend my warm welcome to all present here for the final round of project competition e-MAPCO 2020, organized by EMTSI. Now, I welcome guest of honor, respected Dr. Suresh Yukrande. He is well known among all of us. Sir hardly need any introduction. Sir has completed BE Civil, MTech, and PhD from IIT Bombay. At present, he is a principal at KG Somaya Institute of Engineering and Information Technology, Mumbai. And also, he is a chairman of Board of Studies in Civil Engineering and member of Academic Council and in Research and Recognition Committee of University of Mumbai. He is a former Dean, Faculty of Science and Technology, Dean Faculty of Technology, member of Senate, Management Council, Academic Council, Board of Examiners, Board of Deans, Chairman, Board of Studies in Civil Engineering. He has 33 years of teaching experience and was principal at Engineering College for 16 years at University of Mumbai and 1 year at Pune University. He has published 18 papers, national and international journals, and conference. He has 4 books to his credit: Engineering Mechanics, Fluid Mechanics and Hydrolysis, Irrigation Engineering and Hydraulics Structure, Modeling of Coastal aquifers. He has guided 22 candidates at ME level, and 3 candidates completed PhD and 8 are pursuing PhD under his guidance. He is recipient of Bharatiya Vidya Bhavan National Award for the Best Engineering College Principal 2019 from Indian Society of Technical Education for the outstanding contribution to the academic community and students in the 49th ISTE National Annual Convention Shiksha O Anushandhan deemed to be University, Bhubaneswar on 29th to 30th November 2019. He has been awarded Best Engineering College Principal Award from Indian Society of Technical Education, Maharashtra and Goa section for academic year 2016-17 on 17th February 2017. Also, he has got the Best Principal Award from CSI at Tech Next 18 India Conference and Awards in 2 consecutive years, 2018 and the year 2019. He is a member of various professional bodies such as MISTE, MIE, MIAH, and MISH, and Fellow of ICCEI India. He is a member of National Executive Council of ISTE. So, thank you very much, sir. Now I request Dr. Yukrande to say a few words about today's event. Over to you, sir.
Good morning to all of you. Professor Dasare, faculty members from various institutes affiliated to University of Mumbai, students, participants from University of Mumbai and rest of Maharashtra, and I understand from other states even, for this project competition in mathematics. See, mathematics is a basic subject for engineering. And as you know, for admission to the engineering, basic subjects required are physics and mathematics. So knowledge of physics and knowledge of mathematics is essential, must for admission itself in engineering. And once you are in, I'm talking, keeping the students in as an audience. So when these students are entering in this engineering profession, they have to study this mathematics subject in 4 semesters. Semester 1, 2, 3, and 4. What we say in short, M1, M2, M3, and 4. And as I said in the beginning, mathematics, and that too applied mathematics, or what we say engineering mathematics, is the basis for engineering. Without having a knowledge of mathematics, you cannot become an engineer, a good engineer, a successful engineer. And if we see the curriculum of engineering, any course in engineering, each and every subject, right from first year to final year, there is a relevance of mathematics in every subject. So without knowledge of mathematics, one cannot understand the subject in deep and cannot perform. And if you want to do research also, in that case also, knowledge of mathematics, that is right from 11, 12 to engineering, it's very much essential. And the competition which is organized by these mathematics teachers is a very good platform made available for the students of engineering. Now, if you look at the curriculum of engineering in this University of Mumbai from this academic year 2020-21, rather the revised syllabus which is made available to the engineering colleges right from 2019-20. From second year onwards, we have introduced the mini project. Third year, it may be a mini project or minor project, and final year, it's a project. And that is a separate head of passing for engineering students. And happy to note that, along with that, keeping that perspective in mind, these mathematics teachers have arranged this competition and given a platform for your performance. And we have given a specific guidelines how to select a mini project that is students can select on their own, or teacher can float, or some description can be made available to the students, and from that they can work on this mini project concept. And at last, we have announced that also we can have a competition on various themes in various engineering colleges. There may be, suppose civil engineering is subject or mechanical engineering subject. There are various domains, 7, 8, 10 domains. So on each domain, there can be competition at one or other institute, and we see the performance e-learning platform for the students. And I suppose there are many more entries for this competition, and already some preliminary rounds might have conducted, and some final rounds projects are being selected for this project competition, which are going to be presented live, maybe after this inaugural function, and maybe in the afternoon even. So I wish all the students, those who are participating in this project competition, best luck. And taking part itself is a great thing for the students. Generally, the competitions are there for this basic branches of engineering, civil, mechanical, computer, or whichever the branch. And mathematics, generally, there are competitions, but generally that number is less. But I am happy that faculty from affiliated institutes of engineering of University of Mumbai have came forward and taken this initiative to provide a platform for you. Thank you very much, and all the best.
On behalf of the thank you, sir, for providing your assistance to join us today to enhance our joy and giving enlightening speech on mini projects of mathematics introduced in Mumbai University syllabus. Thank you, sir. Now, we'll start with our session. So before starting with the session, I will introduce today's judges. So we have present over here 8 judges. From this, first I will introduce Dr. V. Jangam. Sir has a PhD in Applied Mathematics from Shivaji University, Poland. His topic of research is 50 years of teaching experience. He has as principal on arts science for 9 years. He has also written books Applied 1, 2, and Applied Mathematics 3 of Mumbai University. Welcome our second guest, Professor. He has done his PhD in the year 1971 from Royal Institute of Science, secured first class with distinction, is third in university. He got National Scholarship and Mathagia Prize. He has completed his MSc in pure mathematics in the year 1973 with class from Mumbai University. After that, he has also did MA in applied mathematics in the year 1977 with the first class. He served in VTTI for 35 years. He was HOD of Mathematics Department for about 10 years. He is co-author of books for Applied Mathematics 1, Applied Mathematics 2, Applied Mathematics 3. He was appointed by university's expert for conducting interviews. He was also chief moderator for some years of Indian mathematics exam. He was involved in syllabus committee, at present giving guidance to students from different sectors and is chairman of a school of Andheri. I welcome you, sir, and it's that I am introducing you. I have worked under Patil, sir, for years, so it's a privilege to introduce her. Our next judge is Professor Desai. He is a well-known person for all of us. Sir has 32 years of teaching experience in KG Somaya College of Engineering, leading mind of science and humanities. He has published papers in journals. He is the author of Engineering Mathematics 1, Engineering Mathematics 2, and Engineering Mathematics 3, as well as Engineering Mathematics 4 of Mumbai University, and member of Board of Studies in different institutes. Subject experts received Best Teacher Award from KG Somaya College of Engineering and Technology. Welcome you, sir. Our next judge is Dr. Narendra Kumar Dasre, sir. He is an associate professor in applied mathematics at D.Y. Patil Group's Ramarao Adik Institute of Technology, Nerul, Navi Mumbai. He holds a doctorate degree in the field of applied mathematics from the KBC North Maharashtra University, Jalgaon, and is actively involved in extensive research in pure applied mathematics in engineering. With 17 years of teaching experience, he is often invited as an expert in various institutes like KBC North Maharashtra University, Jalgaon, Shivaji University, Kolhapur. He is an expert in mathematical software like Scilab, MATLAB, Mathematica, and MAPL, etc. He has authored and reviewed 10 national and international books. He has published 11 research papers in national and international reputed journals. He has been working in the area of approximation of large number. He has also introduced a magic transform, also named as Dasre Gujarati. He is a member of editorial reviewer boards for many internationally reputed journals from USA, UK, Egypt, and many more. He is a member of many national societies like EMTSI, ICA, etc., and international societies like the International Association of Engineers, Hong Kong, IENG, Society of Computer Science, IAENG, Society of Imaging Engineering, Internet Association of Computers and Information Technology, Singapore, and more. His area of interests are page processing, topology, number theory, and applied mathematics. He has delivered expert talks in many seminars, conferences, STPs, and several places. He is also the president of the Engineering Mathematics Society India. Welcome, sir. Our next judge is Dr. Rachna Desai, mathematician by profession and educationist by heart. She is an assistant professor mathematics and coordinator teaching learning center at Somaya College of Engineering, Mumbai. She has many remarkable achievements in academics like gold and bronze medals. She was awarded Best Cadet Award by NSS for her service towards society. She also possesses a certificate for Limca Book of World Record in mass aerobics. She did her PhD from SPNIT Surat. Excellence in research is recognized by Indian Mathematical Society and Society of Spatial Function, India, by awarding a Best Paper Presentation Award in the year 2016-2018. She has also received a research grant from University of Mumbai. She has published more than 15 international journal and conference papers in reputed journals like Springer Elsewhere, IETE, Proceeding, etc. She was served as reviewer of JEE, an international journal of engineering education, chairperson of conferences, invited judges several. She is a member of Indian Mathematical Society, Society of Spatial Function, Gujarat Grant Mandal, Mathematics Teachers Association. Welcome you, ma'am. Our next judge is Dr. Vivek Mishra. He is an assistant professor in Thakur College of Engineering and Technology, Borivali. He has 18 years of teaching experience. He is PhD from Indian Institute of Technology, PHU, Varanasi, in the area of fractional calculus and nonlinear dynamics. His contribution as an academic is two research papers in the Journal of Repute, two books, and organized many conferences and workshops. He has worked on many institutions up till now in his career. I welcome you, sir. Our next judge is Dr. Avinash J. Kamble. He is an assistant professor in applied mathematics at Pillai HOC College of Engineering and Technology, Rasani, Panvel, Navi Mumbai. He holds a doctorate degree in the field of pure mathematics from Karnataka University, Dharwad, and is actively involved in extensive research in algebraic coding theory and fuzzy mathematics. He worked as committee member of syllabus revision for Engineering Mathematics 3 and Engineering Mathematics 4 in the academic year 2020-21 C scheme, University of Mumbai. He has 17 years of teaching experience of Mumbai, wherein 5 years he has worked for Manipal University, Dubai, UAE. He has published 10 research papers in national and international journals. He is a member of editorial reviewer boards of 5 journals from Malaysia, USA, and India. He is a life member of Indian Mathematical Society. I welcome you, sir. Our next judge is Professor Usha Bagh. She is an assistant professor in applied mathematics at Sri L.R. Tiwari College of Engineering, Meera Road, Mumbai. She holds a MPhil degree in pure mathematics from University of Mumbai and have cleared SET exam. She has 14 years of teaching experience. Her area of interest are finite field, algebra, and numerical analysis. She is a hardworking member of Engineering Mathematics Teacher Society, India. I welcome you, all the judges, for the today's project competition. Thank you, sir.
Thank you, ma'am, for the introduction. So firstly, I would like to congratulate all the participants for qualifying into the second round. Now, we can begin with the competition. The first registration number is R10.
Hello.
So is it audible? Okay.
Hello. Hello. Hello, Nitish. Maybe I have a problem with presenting. Just 2 minutes. Huh?
It's okay. So let's start. Good morning, everyone. Today we are here to present about the Fourier series, the mathematical approach to a digital and electronic media, with objective to study about the Fourier series and its application in signal processing. Next slide. Before proceeding directly towards the Fourier analysis, let's clear some basic idea about the periodic function. Is the one which has basics, which is repeated over and over again over the fundamental range. The length of this fundamental range is called period. Here is an example, as you can see in the diagram, of the sine wave with the presentation isn't visible. Yes. Here is an example of the sine x with the period of 2 pi. Now let's go towards the Fourier series. Fourier series is the summation of infinite sines and cosines or the exponential with some coefficients. Here is an equation to represent the trigonometric form of the series, while the other equation is at the bottom of the equation shows exponential form of the series. Not an, en, and are the Fourier or the Hilbert's constant. For this Fourier series, there are also Dirichlet's conditions that need to be followed. F of x must be periodic function. F of x is continuous and has only finite number of discontinuities in the interval. F of x is the final number of maxima or the minima in the given interval. Next slide. Now let's come to the main part of this presentation, that is the application part. Discuss about the two parts of the mainly two applications: signal rectification energy used in commercial building using Fourier analysis. Signal rectification. Maybe the rectifier is the electric device that convert AC, which is periodic, and reverse to the AC current, which flow only in one direction. These are basically two types of rectification: half wave rectification and rectification. In half wave rectification, either the positive or negative of the AC wave passed, while the other half wave is mathematical, it is function, as you can see in the diagram. While the full wave rectification, the whole wave input is converted into one of the or the axis output. Mathematically corresponds to the absolute value. Let's consider the signal wave general equation. Expressing this wave equation in terms of Fourier series gives us the equation of f of x, as the presentation as 1 upon integral 0 to t xt e to the power minus j naught omega t dt. After putting all the values and solving this, we get the final equation as f of x is equals to 2a upon pi in bracket 1 upon 1 minus 4k square. Next slide. For even an equation of the full wave, Cx represents these equations. So basically, rather than having very big example, let's take the basic example at our home appliances that we go across in our day-to-day life. Signal that we receive at our home is from the power station is AC signal, which is further converted using rectifier in our home, and this can be using Fourier analysis. Also in DC to DC conversion using inverter, first it is converted to AC and then transformer changes its voltage and rectifies the power back to DC. Rectification is non-linear process. which changes the spectrum of the signal when we know that even functions are symmetric about the y-axis. Therefore, full wave rectification doubles the frequency and responses the function has even state. Second, put to the next application is Fourier series analysis of early energy used in commercial. A general representation of this energy model of the energy is given as E plus H plus U. Here E is the energy used with the power of hour of day, H is periodic independent variable, and E is the some random variable. Next slide. The simple equation of the further can be represented in Fourier series as the equation 1 shown in the presentation. Here AK, BK are the coefficients of kth sign and frequency, and pk is the period of kth frequency. Here the equation 2 represents both the annual and biannual periodicity. First equation with x subscript represents the annual periodicity, while the second part of y represents the biannual periodicity. Also the d represent day of starting from January 1 to December 31st. Let's take an example of a college where daily energy use may vary over an year in the building. During start of the semester, the energy use increases slowly and decreases at the end of the semester during the exam. That and a Fourier series helps to convert signal from time domain to the frequency domain. It's also used to convert analog to the digital signal. Energy used in commercial building are largely periodic and therefore modeled by the Fourier series approach. With this, we end here. Thank you. Thank you, Aparna, for the presentation. I'll request the judges to ask some questions related to the presentation.
Yeah, hi, Aparna Rachna here.
Yes, ma'am.
Good presentation. I just would like to know about annual periodicity. You have mentioned about annual periodicity in your presentation, right? What is that?
Okay, so let's talk about, yes, ma'am. Annual periodicity means energy used in overall year. It can be starting from 1st of Jan to 31st of December. And if there is a leap year, then annual periodicity, that is the energy used at the overall year, can be changed. So it represents the energy used at overall year.
Yeah, thank you very much.
Thank you, ma'am.
Aparna, hello.
Yes, sir. Yes, sir.
I have a small question. You are talking about the periodic function. If the function is non-periodic, can we represent it by the Fourier series?
Yes, sir. There is also, we know that Fourier series is a large topic. If the function is non-periodic, then it can also be represented in the Fourier series by converting the time domain to the frequency domain. It comes in the other part of the subject and it's so large. So rather than considering those points, we have taken basic examples that can be considered and can be correlated. It can be converted.
Okay. Have you ever founded the Fourier series of a function like fx is equal to x between interval 0 to 2?
Yes, sir.
Fx is equal to x kind of function between 0 to 2. Have you ever founded the Fourier series of this function?
Yes, sir. We are having some topic in the Fourier series. As Fourier series is a topic, sorry, there is a function.
So fx is equal to x when you are finding its Fourier series, you are not converting it into the time frequency domain. Straight away you are finding the Fourier series between 0 to 2, isn't it?
Yes, sir, it can.
Are you with me what I'm talking? Okay.
Yes, sir.
Okay. So this function fx is equal to x between 0 to 2 is non-periodic function, isn't it?
Yes, sir, it's non-periodic.
But you are able to find out Fourier series without converting it in any another domain.
That can be considered in the later part of the subject, as we are not we are at the second year itself and we are not able to study at that deep level, so we have taken only the basic example that we can relate.
Okay. Okay. Thank you. Thank you, Aparna.
Aparna,
Yes.
can you please play the presentation again?
Okay. I'll request my teammate just to present this presentation again.
Okay.
We should play it or just the front page?
Just play it, the entire thing.
Who all was there in this team? Aparna?
Yes, sir.
Hello, sir.
Yes, you
Yes,
were also
yes.
there.
Yes, sir.
Okay. Okay. How you got this idea of this particular project?
Sir, basically starting from application, we thought first about application because then we decide to use the Fourier series in that part. As a second year student, we are limited application about that, knowledge about that. So we stick about it. And we have right now in our semester Fourier series topic. So we choose this topic.
Okay.
And also, sir, it's we can pick basic examples rather than considering a big exit topic. Good.
Okay. Okay. Best of luck.
Thank you, sir.
Sir, Patil sir, you are mute. Please unmute yourself. You want to ask something. Patil sir.
Thank you, sir.
I think Patil sir want to ask something. He's mute. KP Patil sir.
Yes.
Mute.
Yes. Yes. I just want to ask one simple question, though it is not related directly to the application. The basic part, you mentioned that for the Fourier series, the periodicity of the periodic function is required. Now, my question is, tan x is a periodic or not?
Sir, it is non-continuous, but so we can apply Fourier series directly to that. At pi by 2, it is non-continuous.
Okay, very nice. Now, another one point I just want to clarify that when you have given all these what is called applications related to exactly what digital and a question arises that as madam asked just now, the periodicity, which is maybe 2 pi, maybe general water, maybe, is the period infinite period is there into account or just finite period it is to be?
So when we used to
Function,
solve our basic
which is a
example,
finite period is to be considered.
we can also have in discrete condition it is mentioned that it should be have finite discontinuities in the interval. Interval can be finite or infinite. When we used to solve some problems which are given to us to solve, there used to be in condition from minus infinity to infinity. So it can be taken, interval can be taken as infinite, but the condition is.
Thank you.
Yes, sir. Yes.
Thank you so much, Aparna, for such a presentation.
Thank you.
Now moving on to the next group, R13. R13.
Hello. Am I audible?
Yes, you're audible.
So, good morning, everyone. Our topic is complex form of Fourier series. So, our registration number is EMAPCO R013. Let's start with the abstract of the topic. So, Fourier series is one of the oldest and well-known techniques in the field of mathematics and engineering mathematical work. A Fourier series is a way of representing a periodic function, possibly infinite, sum of sine as well as cosine functions. This paper will focus on Fourier series of complex exponentials. Fourier series are sum of phi n, which will be approximate periodic, complex valued functions with arbitrary precisions. Of the various possible methods of estimating complex valued functions, Fourier series are especially attractive because of the uniform convergence of because of the uniform convergence of the Fourier series. Is guaranteed for continuous as well as for the bounded functions. It is relatively simple to effect, as well as it is ubiquitous in physical phenomena. Main advantage of Fourier series is error minimization. Main highlights of the paper are that it defines generalized Fourier series and important properties are also described and explained with appropriate example. So let's start with the mathematical idea. So the basic relation of trigonometric and exponential term, what we have learned is cos x is equal to e raised to ix plus e raised to minus ix divided by 2. And sin x is equal to e raised to ix minus e raised to minus ix divided by 2. Then standard Fourier series is f of x is equal to a0 plus summation of n equal to 1 to infinity an cos nx plus bn sin nx. From the above identity, we can write a generalized polynomial expression which is equivalent to summation of n equal to minus n to n cn e raised to inx. So everyone might be wondering, how did this term come? Basically, we have a0 and an are constant terms. We have taken them together and formed a new constant as cn. And cos of nx is numerically equal to e raised to inx. But for the term bn sin nx, it will be 0 because in Fourier series, always the sine term value is 0. That's why the whole term is neglected. So this is the basic generalized form of complex Fourier series. So let's look at the implementation of this mathematical idea. So basically, a Fourier series can be defined into 4 intervals: 0 to 2 pi, minus pi to pi, 0 to 2l, and minus l to l, where l is an arbitrary constant, means we can take any value of l. L does not have any restriction of taking value. So for 0 to 2 pi interval, standard Fourier series will be f of x is equal to summation of n equal to minus infinity to infinity cn e raised to inx. Means our equation can be defined from minus infinity to infinity. It could be an infinite set of functions, where the value of constant cn will be given by equation cn is equal to 1 by 2 pi integration from 0 to 2 pi f of x e raised to minus inx dx. So the limit, since the interval is 0 to 2 pi, our limits for the cn is 0 to 2 pi. Similarly, for the next interval, that is minus pi to pi. Standard Fourier series will remain the same since a standard Fourier series does not involve the intervals. Whereas in cn, the equation is just the same with the limits changing from minus pi to pi. Then for 0 to 2l, now for the arbitrary functions, the standard Fourier series remain the same. Just the power of exponential, what we had for the pi term, is divided by the arbitrary constant. So f of x is summation of n equal to minus infinity to infinity cn e raised to inx divided by l. where the value of constant can be given by here all from the previous intervals. All pi value pi is replaced by L, and exponential term power is also divided by L. So Cn is 1 by 2L integral from 0 to 2L f of x e raised to minus inx by L dx. Similarly, for the fourth interval, that is minus L to L, standard Fourier series remains the same, whereas the value of constant also remains the same, just the interval changes, that is minus L to L. Then, a very important note when it comes to solving any question of a complex Fourier series, that in complex Fourier series, there is not, it is not necessary that we should check for even or odd function. And in complex Fourier series, if trigonometric or hyperbolic function is given, then it will be preferable that we convert it into exponential form, which will be much more easier to solve. Then, while solving any question of complex Fourier series, these 13 formula is always coming into application. That is, first one is integration from e raised to x dx is e raised to x. That is a very common integration we have. E raised to 0 is 1. Anything raised to 0 is always 1. That's also one of the important formula, since limits what we have has interval 0 to pi, 0 to 2 pi, and 0 to 2l as well. So this formula comes into application there. Then one more important formula is e raised to plus or minus I n pi is 1 raised to n. Cos ax, we had already seen the formula of cos x, that is e raised to x plus e raised to minus x divided by 2. The form, so here we have only the constant term as a. Similarly for sin x, and when coming to hyperbolic term, cos of hyperbolic ax will be just the sign change of the previous two terms. Then eighth formula is sin of minus x is minus sin x, and cos of minus x is cos x. Sin hyperbolic minus x is minus sin hyperbolic x, and cos hyperbolic minus x is cos hyperbolic x. And one of the common formula that we might have learned since our childhood is that imaginary terms square is minus 1. So let's take an example to understand the same. So we have a question from one of the university papers, that is obtain complex Fourier series for f of x is equal to e raised to ax in interval 0 to a. So when we check with the standard interval, it matches with the standard interval 0 to 2l, since L could be any arbitrary function. So we consider the standard Fourier series of 0 to 2l. Here, when we compare the two intervals, 2l is equal to a, therefore L is equal to a by 2. This we require since we have to find the value of Cn. Because Cn's formula is 1 by 2l integral from 0 to 2l f of x e raised to minus I nx by L. Here in power, L is the single term. So we had to find the value of L in terms of a. Then we substitute all the value of L, like 2L was a. So we have just substituted all the values and changed the limits. Then in the third step, we have just used the law of indices. Since there is e raised to a, like first term has e raised to a power and second term has multiplied by e raised to some power. So we use the law of indices as it will become e raised to a plus b, and we have just cross multiplied. And from the in the next step, we have just taken x common from the numerator. This is because in the next step of integration, we will have to integrate it with respect to x. So for integrating the term with respect to x, we had seen the formula e raised to x is e raised to x itself in integration. But here, since x is multiplied by a constant, we need to use the chain rule. That is, we need to take integration of a constant into x, that will be constant itself. That's by chain rule. Then we apply the limits. Since the limits are from 0 to a, we have got the next value purely by substituting. Then we simplify it to the next step. We have just taken, we have just once again used the law of indices. Here it is e raised to a minus b. So we have just substituted it as e raised to a into e raised to minus b. Then We know the formula, we have seen the formula that e raised to minus 2i n pi is 1. So that term e raised to 2i n pi is just neglected. Then in the next step, when we see the two terms, a by a square minus 2i n pi is common. So we can take the things common and get the finalized step as Cn is equal to 1 by a square minus 2i n pi into e raised to a square minus 1. I is never allowed in the denominator since we cannot convert it into real and imaginary part, so we rationalize it. Then we get the final Cn value. Then we just substitute it in the standard Fourier series and obtain the required answer. So applications of Fourier series. Basically, this complex Fourier series is taken into 4 major applications, that is communication, image processing, data analysis, and cell phones. In communication, complex Fourier series is required in signal behavior. It is used for filtering, amplifying, and in communication channels. In image processing, 4 major applications are transformation, representation of an image, encoding an image, smoothing an image, and sharpening an image. We all might have been using image editors. So basic application of image editor is just because of Fourier transform, because Fourier transform is that crucial image processing tool that can decomposes a picture into its sine and cosine components. Then in data analysis, a signal and noise estimation is done by this Fourier series by simply converting into its sine and cosine components itself and encoding the statistics. In cell phones, cell phones has inbuilt high-speed cellular data connection, and this is just possible due to this Fourier series only. And in previous data analysis, we saw noise estimation. Similarly, here it's used for sound building, that is done by splitting and a recombination of sine and cosine waves. Conclusion. A Fourier series is beneficial in many applications, starting from experimental instrumentation to rigorous mathematical analysis techniques. Because of modern development in digital electronics, including numerical algorithms, there's most famous algorithm FTT, which is known as fast Fourier transform. The Fourier series has become one among the foremost widely used and most useful mathematical tool to any scientist. Thank you so much.
Arthur, can I ask you a question?
Yes, ma'am.
You talked about communication channels, right? Fourier series are used in communication quite a lot. Do you know how Fourier series is used in WhatsApp?
Ma'am, could you pardon? I guess I'm not able to hear you properly.
Yeah. Do you know where the Fourier series is used in WhatsApp?
WhatsApp. Not really, ma'am. Fourier, basically, it has a application of Python, and in Python there is use of Fourier series.
Okay.
Basically, WhatsApp is an application and done by Python.
Okay.
So there I'm not that sure about using in Python about Fourier series. I've not just read about anything since I am also from second year itself. And I've
No
just
problem. Try to find out. You will find really very interesting application of Fourier series in WhatsApp.
Sure, ma'am.
Others?
Yes, sir.
Okay, I've just gone through your presentation, and the main highlight of your presentation was complex form of Fourier series. So that clearly indicates that you have a thorough subject knowledge about your concept. Okay, that complex form of Fourier series, then how it has developed and what are the important components of Fourier series. Everything you have highlighted, fine. But this computation is about synchronization of mathematical concept in tune with the technical applications. we would be very much happy to know at least one of the applications what you have mentioned in digital communication, image processing. If you can just give one application and how this mathematical concept would be applicable in that particular
Uh, Sir, your voice isn't audible. Like your voice is breaking, sir.
Hello.
Yes, sir.
Hello, am I audible?
Yes, sir.
Okay. Just elaborated all the mathematics.
Sir, unable to hear you.
Others, please stop your presentation.
Okay, sure.
Hello.
Yes, sir.
Yeah.
Others, can you introduce yourself, please?
Okay. Yes, sir. My name is Adarsh, and I'm in second year of engineering, and I'm basically in chemical engineering.
Okay. Okay. Now, I have this question for you: that why we need to do this Fourier series?
Sir, yes.
Generally, students think that we are just giving them burden on their mind. There is a simple function, we are expressing it in the form of a Fourier series. Why we need to do this?
So basically, that is mentality of every student. That why do we even study mathematics is the main question. Like
no. Don't go to the larger picture. Come to this focused your domain which you are presenting. Why we need to express a function in the form of Fourier series?
So basically, we express everything. Basically, a Fourier series is a major application in day-to-day life. Like even we are seeing image. Like I have already said, we are using image editor and all. Everyone are doing that normally, like without knowing what's the use of it. Like how is it being done? No one is digging, no one is just trying to explore what is the main reason behind getting that thing done. So basically, that's why we are learning a particular subject. Like in Fourier series itself, it is combination of sine and cosine, and sine and cosine are basically wave functions. And wave, even what we are speaking right now is a wave. It's just because of some frequency, and frequency is just Fourier series. Fourier series is dealing with all kind of frequency.
Okay. Actually, what I expected from you that chemical engineer you said, since you are engineering a student, so you need to do a lot of computation. Like if you ask the scientific calci, what is sine 45 degree? So if the calci doesn't understand, it is the ratio of two sides of a right angle triangle. Okay, but still it gives you the value of sine 45. There might be a coding taught to the calci, or coding is
Yes,
fitted
sir.
into the calci. So how the sign might be interpreted to the language of the calci, so that it can interpret what is sine 45, and this is what you are asking. Okay, so that is the one application of expressing any function in the form of series, because you cannot teach any computational machine that this function means this. You can teach it in the form of series. You can give the input you can put the code in the form of series. So that is one very simple application. Others, what you are talking about, the representing signals in the form of series, that is one another application. One another word you have used in your presentation, that Fourier series follows uniform convergence. Okay, do you understand what is uniform convergence is?
Yes, sir.
Oh, can you explain it, please? Oh, I think he got disconnected. Sanskriti, I think the presenter got disconnected.
Yes, sir. I'll contact him. Just 1 minute.
Anybody else was there in that team? He was alone. Yes, we can go for the next presentation then.
Okay, the next number is R4.
Yes, Sahil is gonna present. Actually, due to some technical issue, we are not going to present it through presentation. We are going to present it through PDF. Will that be okay?
Yes,
Yes,
it will be
yes.
okay.
Okay, thank you very much. So can I start now?
Yes, you can start.
Okay. So good morning, everyone. My group is going to present application of Laplace transform in engineering. We have chosen this project because we believe that mathematics is not just about numbers, equations, computations, or just algorithm. It is about understanding. And there is a very famous quote by Paul Helmers that the only way to learn mathematics is to do mathematics. Here we are going to discuss some of the widely used application of Laplace transform. Now, before jumping towards the Laplace transform directly, we first need to understand what is Laplace transform exactly. So the concept of Laplace transform plays a very important role in various fields. Here we are going to understand some of the very basic but important aspects of Laplace transform and its application, especially in mechanical engineering and in control systems. So here is a little background about what Laplace transform is. This transform is named after Perry-Simpson Laplace. Laplace transformation is a very powerful transformation tool which literally transforms the original differential equation into algebraic expression. Now suppose that f is a real or complex valued function of a variable where f is greater than 0. Then its Laplace transform is given by integral 0 to infinity e raised to minus st ft dt. Now here time domain and frequency domain are two new concepts which came into picture. So in time domain analysis, we break the input into impulsive component and the sum of the system responds to all of these components. While on the other hand, in the frequency domain, we break the input into exponential component to form e raised to st. So now we can conclude that the Laplace transform is a tool to map signals from time domain into frequency domain. Now the question arises, why exactly do we need to convert time domain into frequency domain? And the answer is the value of a function of a signal at a given instant is given at the time domain. But in the case of frequency domain, the rate of signal is given. So that is why we need to convert from time domain and into the frequency domain. Now, there are two necessary conditions for existence of Laplace transform. First is the Laplace for the function is a function f is said to be piecewise continuous. What is piecewise continuous? A function is said to be piecewise continuous if it is broken into finite number of subinterval and is continuous in each subinterval. And the next condition is it should be of exponential order. A function f is said to be of exponential order if there exists constant m and c such that bounded f is less than equal to m e raised to ct. Now we can conclude that for any function to be Laplace transform existence, there should be the function should be piecewise continuous in 0 to infinity and it should be of exponential order. Then and then only the Laplace transform will exist. Now from here onwards, our next member will take on.
Good morning, everyone. Now we will see some application of Laplace transform in engineering. Application in control system. A control system is an interconnection of components forming a system configuration which provides a desired system response. Here, the components are classified as electrical, thermal, and so on. All these components can be described by mathematical modeling such as integral differential equation of various order. The output of the control system for any input can be obtained by solving such equation. We have explained the process by diagram. In this example, differential equation is difficult to solve, so we need to solve it by using Laplace transform. Converting this equation into S domain by using Laplace transform property because all computation can be easily performed in frequency domain. Now, finding required variable A, B, C using inverse Laplace, and finally the time domain required equation is obtained. Now, for better understanding, here is a mathematical concept behind the control system, which you can see by taking Laplace and resolving it into Laplace transform, we get desired output. Application in mechanical engineering. Examining the suspension system of the car, the important element in the system are the mass of the car, spring, and damper connected to the body of the car, as well as associated variable displacement and force. The equation of this mass spring damper system can be obtained by Newton's and Hooke law. This equation is difficult to solve, so we need to convert it into Laplace transform using property of Laplace transform in derivative. Now, finding required variable omega A, B, C, D by a partial fraction method. And finally, we got a required equation obtained by inversing Laplace. From now, our third member will take on.
Good morning, everyone. Conclusion of the project. By all the details from introduction and application of Laplace transform, we come to know use of Laplace transform in real life and in different field of engineering. Laplace transform is a powerful tool using in a different areas of mathematics, physics, and engineering. With the help of application of Laplace transform, many applications, many research software have made it to simulate the Laplace transformable equation directly, which has a good advancement in the research field. We are very thankful to our principal and teacher to guiding us for this project. Thank you so much.
Sir, I'm Professor KP Patil. Can I ask you a question? Hello?
Yes.
Hello. I think you have rightly mentioned that one of the application, I will say one of the application of Laplace, you stress on solving the equation in easier way. But do you agree with me that in second semester you learn the differential equation, and I think for that, it compared to this, it is always easier one. How do you claim that this is only a very, giving more emphasis with using a Laplace transform? Because when you do Laplace transform, you go with the inverse, it takes many steps. So under what right you say that it is better? Application, I agree. Can you explain me why it is better?
Sir, yes. Because till now we have studied the various integrals and differential properties, and to solve differential problems in a very simpler way, we just in the second semester only we just find out that Laplace transform is one of the very simpler way as of now. Till now we have studied till Laplace transform. In next semester, I am sure that we are going to encounter various simple techniques which are used in day-to-day life, but till now we have studied various function, and we found that Laplace transform was one of the easiest way to resolve the problem.
Hello. Hello.
Yes, sir. Yes, sir.
You have said in the start that Laplace transform exists if the function is of exponential order.
Yes, sir.
What does it mean?
So this means that the function should be bounded and it should be less than equal to m, whereas m is constant, m e raised to ct.
What is the meaning of it? It doesn't look abstract. Something is said. Why it should be like this? Have you thought about it?
Yeah, sir. So
Bolo, yes.
sir, so as of now, we have not deeply think about it, but that we thought that it is a condition, so it should be fulfilled. That is
Yes. Okay. So my request to you that you think about why this should be there.
sure,
Okay.
sir. Sure,
Okay,
sir.
Best of luck.
Thank you, sir. Thank you, sir, very much.
Yes, Rachna here.
Yes, ma'am. Yes, ma'am.
Can you take me to the first application?
Yes, ma'am. Sahil.
Next one. Still next. Okay. So here the equation is formed, right? D square y by dt square. What is y here? Function of t. Am I right?
Yes, ma'am.
But what is the physical interpretation of y? Which real world thing you have written it here as y?
Sorry, ma'am. Your voice. I could not listen.
Here, y you are representing in mathematical form, right?
Yes.
In real life, that would be something.
Hmm.
What is that physical thing? Or what is yt? You're
Ma'am,
solving for y,
yes,
right?
ma'am. Yes, ma'am. Yt is an input of control system.
Okay. And what
Yt
will
is an
be ys?
ma'am. Then, ma'am, ys is an frequency. We converted this time domain equation into frequency domain equation because computation in frequency domain is easier. So that's why we convert it into S domain. And finally, the equation here is an output of the control system.
Okay. Take me to the next example. Next one. Here, what is x? F of t here you're writing, right?
Ma'am, this is an equation of an clipper clamp mass spring damper system, which is obtained by mass Hooke law and Newton's law.
Okay. So here f is different than what f was there. This is the common mistake which student does, that they consider y as a general function and you are solving for y. So this you should know that always the equation you are solving for a real life meaning is different. Okay.
Yes, ma'am.
Yeah.
Hello, I'm Narendra Kumar here. Okay, so please take me to the slide 13. Yeah. Previous 12. Yeah. Okay, so you have declared y is going to be the function of t. Okay, but if you see the last equation, you are taking the Laplace of function of s. So yeah, yes, last equation you can see in this slide, you are taking the Laplace of y of s. So I am confused about this. So can you please explain me?
Sir, the first equation that
Whether your variable is t or whether your variable is whether you are taking Laplace of frequency domain or you are taking Laplace of time domain.
Sir, the first equation is an equation in time domain.
Okay.
Laplace
So
transformation, we convert it into S domain because all the computation can be easily performed in frequency domain. So that's why we converted time domain into frequency domain.
I want to just understand the term L of y of s.
Laplace transform of y in S domain or frequency domain.
So you are taking Laplace transform of a frequency domain, right?
Yes.
Okay, fine. So Laplace takes us from the time domain to frequency domain. That
Yes,
is the
sir.
concept. Okay. Now
Hello,
from
hello. Hello,
where we
sir.
will
There was a mistake. That was a inverse Laplace.
what?
Sir, there is a mistake. Some mistake in this PDF. There was that is not right. There was an inverse Laplace.
Wait. Brijesh, are you a team member of this?
Yes, sir.
Okay. What was the mistake? Take to the slide 12.
Sir, it's apologize. Sir. Sorry, sir. There was a mistake. That was an inverse Laplace, sir. It's mistake, sir.
But you are writing, see the previous statement taking Laplace on both sides and neglecting the initial conditions. You are taking Laplace of this equation, given differential equation 1, no?
Yes, sir.
Yeah, then you are taking s square into Laplace of y of s. So where is the inverse here? We don't need the inverse here. You are taking the Laplace transform.
Sir, actually, by using Laplace transform property of derivation, we converted this equation into frequency domain equation. And then at next slide, by using partial fraction, we find
Be the
A,
previous,
B.
be on the previous slide only, or okay. If you go to the next slide, also you have written Laplace transform of y of s. You can see the first step, Laplace transform of y of s. So I just
Yes,
want
sir.
to understand what is Laplace transform of y of s.
Sir, in this slide, we have find A, B. 16 is neglected, and we have find A, B, C by partial fraction.
No. My question is not what is the right hand side. My question is on the left hand side. I want to understand what is Laplace of y of s. That is only the thing. Okay.
हाँ सर, उधर सर शायद से लैप्लस ऑफ इनवर्स ऑफ वाई वो वैस लिखना था, हमारा थोड़ा मिस्टेक हो गया शायद से.
Okay. No problem. Fine.
हाँ अभी समझा
Okay.
सर.
Yeah. Okay. Yes, I am done. Thank you.
I just want to say something here. YT and YS, you should use different notations whenever you are applying Laplace of something on function, right? You should have a different notation. So this YS and this YT are different things. Okay. This should be written as Y bar S or capital YS, just like here you have written by capital S. You should do that.
Yes, ma'am. Sure, we will take this into account from next time onwards.
Yes.
So this is a very common mistake done by the students. You need to understand the variables properly and their real life meaning. Okay. So you are been restricted to only two domains, the time domain and the frequency domain. So the notation you use, as the Rachna madam said, that they have some real life meaning. Okay, so we cannot just write any variable anywhere, and that's what I was about. Okay, so you have to be very careful when you write L, their variable L inside the bracket, you must have T. Okay, there is no other variable, and when you are using Laplace inverse, then the variable will be S. Okay, so thank you.
Yes, sir. We will take this into account, but this was our first attempt towards the Laplace transform and its application. So that is why this chaos kind of thing has happened.
That's okay, no problem. We keep on learning, no problem.
Yes, sir. Thank you. Thank you very much for your suggestions, Rachna ma'am and sir. Thank you.
Pleasure.
Yes, ma'am.
Thank you, yeah. Now the next presentation is R5. Okay. So I can start now?
Yeah.
Yes. Okay, so thank you. Now, please tell me the anyone. My screen is visible now. Yes, it is visible. You can start.
Okay, okay, thank you. Okay, so good morning all. The project registration ID is EMAPCO R-R-005-HDV. Then next slide is my topic of a project is analysis of electrical circuit. This is a project based on application of a Laplace transform. In this project, we see application of Laplace transform in electrical and electronic engineering. The analysis of electrical circuit using Laplace transform is a powerful efficient than the transit analysis become solution of a second order and ordinary differential equation into the simplified algebraic equation. Then next is the introduction part. Today more than ever, electronics are an integral part of our everyday lives. They contribute to every aspects of our way of life, from lighting a space around our work environment to exploring chance to read years. But behind each and every electrical appliance or device, no matter what task it was designed for, lies a vast system of electrical components that must function as a whole. The using Laplace transform in circuit analysis lies in automation includes potential conditions information space to provide complete transit and steady solution. Next is a mathematical idea. Mathematical idea they include in first is the Ohm's law. Ohm's law states that the voltage across conductor is directly proportional to the current flowing through it, provided all physical conditions and temperature remain constant, that is V is equal to IR. Then next is the Kirchhoff current law, that is the KCL. Kirchhoff current law, often shortened KCL, states the algebraic all current entering and existing node must equal to zero. That summation of I of in is equal to summation of I of out. Then next slide is Kirchhoff voltage law. For the closed loop, path the algebraic sum of all the voltage around any closed loop in a circuit is equal to zero. That is the summation of V equal to zero. Then next is the RC circuit. It is an electrical circuit composed of resistors and capacitors. It may be derived by voltage or current source, and this will produce a different responses. A first order RC circuit is composed of one resistor and one capacitor, and it is the simplest type of RC circuit. Then next is the AC circuit. Alternating current is an electrical current which periodically reverses directions and changes its magnitude continuously with a time in constant to direct current which flow only in one direction. Then next is the application. In application include one example is a find impulse responses of the following circuit. Then time domain solution the Laplace converted equation by using inverse Laplace transform. We convert algebraic scheme to S domain function, that is V of V naught t is equal to 1 of RC into E of minus 1 of RC U of t. Then here we find the transfer function, that is H of S is equal to V naught of upon V E S. Then next is here we get some answer for the both the cases, that is H of S is equal to Laplace inverse of H of S equal to 1 upon RC e to minus 1 RC is U of V. Then one of the main reasons for using frequency domain representation of the problem to simplify the mathematical analysis for mathematical system governed by linear differential equations, a very important part of a system with many real-world applications, converting the descriptions of the system from the time domain to the frequency domain converts differential equation to the algebraic equations, which are easier to solve. Then next is the conclusion. In this introduce some of the fundamental ideas underlying electrical circuits, we have considered the many ways in which electrical concepts affect on our lives, some of the technical ideas. Then this is included the basic of electrical circuit. We also made brief journey into the world of signal and electrical processing, where electrical concepts play dominant role. Then convolution in time domain can be obtained by multiplication in S domain. Integral differentiation equation of the system can be converted into simple algebraic equation. So basically, Laplace transform save our time and energy in the analysis of complex circuit. Then next is the outcome. So in basically for this project, we search about a lot of topics, and this topic was the most interesting one. And considerably, we are learning that same thing in this year. Then it is a fact that when you know the real life application of something, you are more curious to learn that thing, and we all have experienced that feeling during the course of this project. We now feel that as engineers, this our primary responsibility to know about how to think happen, so that we can contribute to the betterment of the society. So thank you so much.
Hello.
Yes, sir.
Hello. Hindvi, how you got this idea?
Yes, sir. So actually, the Laplace transform is one of the most important tools used for saving ordinary differential equations, and specifically periodical differential equation, as it convert partial differential to regular differential, as well as just seen. In generally, the Laplace transform is used for application in time domain.
My question was how you got this idea of your project, what you have presented here. How this idea has generated in your mind.
Yes, sir. We are in use of daily to daily life of various electronic circuits. So electronic circuits are represented in a differential equation. So this differential equation we have to solve in Laplace transform. So we are got the idea to this project. So explain the how electronic circuits have used. Hello, sir.
Yeah, I'm able to hear you. Hello. Ganesh?
Yes, sir.
Ganesh, do you know that there are some differential equation where Laplace transform cannot be applied? Because when you are thinking about this project, you know the limitation of your application also. Are you aware?
No, sir.
Okay. Okay, I'm done. Thank you.
Hello.
Thank you, sir. Yes, sir.
This is Avinash Kamble here. Ganesh,
Yes, sir.
your project title is Analysis of Electrical Circuit. So what exactly you are looking for analysis? What do you mean by analysis? Would you interpret your title of your project?
Analysis of electrical circuit means we have to find the unknown factors, that is current, voltage, and resistance. All these unknown factors we have to find in that circuit, in that electrical circuit.
And how does Laplace transform will help you while finding those things?
Sir, electrical circuits are represented in a differential equation. So the difference, all these equations are harder to solve and have various methods also, but in Laplace transform helps to convert this differential equation into algebraic equation. So, and we have a standard for functions, standard formulas for applying that formulas in algebraic equation. We got a S domain values, and from applying inverse Laplace, we got these values in time domain.
Yeah,
Hello, sir.
Yeah, I'm done. Thank you.
Thank you, sir.
Thank you, Ganesh and Hindevi. The next number is
Okay.
R6. R6.
Good morning, everyone. Shall I start?
Yes, you can.
Yes, yes.
Good morning. The title of our project is The Flow Rate of Blood. When we talk about life, the flow of blood through our body is the main reason we are alive today. The flow rate of blood can be calculated with the help of integral calculus. Surprising, isn't it? But yes, integral calculus is used to derive Poiseuille's law, which is the main concept behind flow rate of blood. Hence, the aim of a project is to study the use of integral calculus to calculate the flow rate of blood through our blood vessels. The mathematical idea for a project is integral calculus. For any operation in mathematics, there is always an inverse operation. For example, for addition, there is subtraction. For multiplication, there is division. Similarly, for differentiation, we have integration. In mathematics, integration is used to describe displacement, area, volume by combining infinitesimal data. This is the representation for integration and definite integral. Integration can be simply explained with the help of an example. Considering a tank that is filled from a tap of water, the input is the flow rate from the tap. By integrating this input, that is, by adding up little bits of water, we get the total volume of water in the tank. This diagram shows us the correlation between integral and derivative. Poiseuille's law. This law is a fluid dynamics concept which gives us the flow rate of a fluid. The main applications of Poiseuille's law include flow rate of blood, the flow rate of water through pipe, etc. It states that the flow rate of a liquid flowing through a capillary is directly proportional to the pressure of the liquid and the fourth power of the radius of the capillary and is inversely proportional to the viscosity of the liquid and the length of the capillary. This equation represents the equation for Poiseuille's law. Flow rate Q is defined to be the volume of fluid passing by some location through an area during a period of time. In symbols, it can be written as Q is equals to V by T, where V is the volume and T is the time period. In this diagram, we have considered a small cylindrical part with area A and length D. The volume of this cylinder is given by A into D. As per the definition of flow rate, Q is V by T. By substituting A into D in place of volume and by substituting velocity in place of d by t, we get the equation of flow rate as Q is equals to A into V. That is, flow rate is the multiplication of area into velocity. Coming to the derivation, we consider a vein or a blood vessel in the shape of a hollow cylinder with blood flowing through it. In this diagram, Q is the flow rate of blood, R is the radius of the blood vessel, L is the length of the blood vessel, P1 and P2 are the pressures at both ends of the blood vessel, eta is the viscosity of blood. And here comes the law of laminar flow, which tells us that any fluid flows in layers and The velocity of the fluid near the walls is the minimum because of the friction with the walls, and it is the maximum at the center. Here comes the need of applying integration in this derivation. We need to find velocity and flow rate at certain points and then integrate it to find the total flow rate. The law of laminar flow gives the velocity of blood. By multiplying this equation by 2 pi r, that is the area of the ring, we get flow rate at a given point, that is at distance small r from the central axis. This equation of flow rate can be integrated over a domain of 0 to r, where r is the radius of the blood vessel, to get the total flow rate of the blood. This equation can be further simplified by using rules of integration to get the final equation of Poiseuille's law, which is Q is equals to pi P into R raised to 4 upon 8 eta into L. This is the final equation of Poiseuille's law, or the flow rate of blood. From this project, we can conclude that integral calculus is used to derive Poiseuille's law that gives the flow rate of blood. The measurement of blood flow rate provides vital information for diagnosis of various diseases. Also, it is necessary during surgeries, transplantations, and dialysis. Flow rate measurement can be beneficial in developing new health instruments in future. We successfully studied that integral calculus has been applied widely in biological fields. Some of these include calculating amount of blood pumped by heart by dye dilution technique, or calculating rate of growth of trees, and also calculating rate of growth of population of any species. Biology also includes a branch called biocalculus that uses calculus to solve many problems. These are some of the references we used for our project. Thank you, everyone.
I have a question for you.
Yes, ma'am.
You mentioned that there is always an inverse operator.
Yes, ma'am.
Is it true?
Like for some operations in mathematics, we have inverse operations.
For some or always?
For some.
Okay, because in your presentation you have mentioned always.
Yes, ma'am.
So just clarify on that, whether it is always or some.
When we wanted to explain integration on basis of differentiation, so we tried to correlate it, and so we use the term inverse.
Just check this complete concept of having inverse of something in mathematics, right? You cannot generalize the statement. So I just request you to go through this concept once again. Can you take me to the diagram which was on slide number 4, I guess?
Yes, ma'am, sure. And this one?
Yes. You said this explains the concept of integration and derivation. Can you just elaborate little more on this figure?
Ma'am, integration is a concept where we can add infinitesimal data, and by combining, we get a total amount or quantity. Whereas differentiation, we need to divide to find out the smallest piece. So that's the correlation between integration and derivation.
I just could not relate this this water filling thing with what you said, right? Integration and derivation.
Actually, the flow rate of water is considered as the input, and when we integrate the flow rate, that is like by adding the little bits, we get the total volume.
Okay, thank you.
Thank you, ma'am.
The next number is R6. Sorry, the next number is R8.
Okay, so now I'll start. Good morning, everyone. Our project name is Vectors Unleashed. Let us look what are the objectives of our project. First, we'll understand the various types of vectors and elaborate them in details. Next, with the help of mind map, we will understand the various forms of vectors and its arithmetic. We will see a small puzzle which will check our understanding. And finally, we will see some applications of vectors in real life. So let's get started. Firstly, vectors vectors are used in our day-to-day life knowingly or unknowingly. Learning vector algebra is important step in students' ability to solve problem. The vector algebra is much more easier than the geometry, which gives us advantage to compute the problems. Vector algebra was invented to solve two-dimensional as well as three-dimensional problems. So we will understand vectors by using mind map. About mind map, it is a diagram which visually represents the information. It shows the subtopics related to the main topic in more cleaner way, helping us to get a clear picture of the entire concept. It is a good tool for teachers as well as students, which breaks the topic and connects to the main topic, which expands, which gets in the one big umbrella. So let us look at the mind map. So this is our mind map, and our central topic is vectors. So vectors are the physical quantities which possesses both magnitude as well as direction. It can be imagined as an arrow where its length is its magnitude and arrowhead pointing is its direction. Now we will check our first topic, that is types of vector. So I'll just go to the first node of the vectors, that is types of vectors, and expand it. So as we can see the sub nodes are the types of the vectors. So we have zero vector, unit vector, position vector, co-initial vector, and so on. To see the definitions of each of it, we will just again expand the sub node and we can read the definition. So as we knew about the types of vectors, we will go into deeper concepts like vector algebra. So first we will see addition. So there are certain laws of addition which we will see. So the second node here is laws of addition. So I'll here again just expand this node So we will first see triangle law of addition. It states that if two vectors taken in order by representing sides of a triangle in magnitude as well as direction, then the third side of a triangle is the vector sum representing in direction as well as magnitude. The second is parallelogram law. It states that if two co-initial vectors, which means vectors starting from the one initial point, same point, taken as a sides of a parallelogram, then then the vector sum is represented by direction and magnitude by the diagonal of the parallelogram. Now we will see vector multiplication. First vector multiplication type is dot product. So again, I will expand the node and see the dot product. So dot product is defined as the product of Euclidean magnitudes of two vectors and the cosine angle between them. It can be calculated as product of magnitude of first vector, magnitude of second vector, and the cosine angle between them. The next topic is cross product, which results into another vector which is perpendicular to both the vectors. So cross product can be calculated by its magnitude can be calculated by taking product of magnitude of first vector, magnitude of second vector, and sine angle between them. So these were some basic algebra which we can perform on vectors. These are some types of vectors. This is the representation of addition, and these are the cross product and dot product representation. So we'll check our understanding by solving this puzzle. By solving this kind of puzzles, we can cover the whole idea of what we have learned. So these are the answers for the crossword. Now applications. Vectors has huge amount of real life applications. These are some which we have listed. Vectors can be used in graphics, crosswind, in sports analysis, and many more. To see them in detail, I request to all judges to watch this small video created by our team. Conclusion. In this project, we have learnt about some types of vectors and their algebra. We have also seen its applications in real life, which shows us vectors is really essential topic to learn. We have also seen how mind map simplifies our learning approach and puzzle makes real fun to grasp the knowledge of what we have learned. In this project, we have tried to come up with a innovative way to learn mathematics. Thank you.
Hello, Anirudh.
Yes, sir.
In your presentation, you mentioned zero vector.
Yes, sir.
What could be the direction of a zero vector? And if it doesn't have a direction, why should we call it vector? You have used the
It
word
has.
zero. Yeah.
Yes.
Zero vector has its length 0.
Okay. Length 0, that's why. So it does have a direction.
Yes, sir. It can be have direction, sir.
Okay. Okay. Thank you.
Thank you, sir.
You said vectors are used in games, right? Can you give me any 3 example of games where vectors are playing a major role? Other than cricket, which you mentioned.
We can take example of basketball. We can take example of basketball where the starting a direction is important, and we have to also consider the weight of ball, which is of magnitude. So we can compute the force, which is a vector quantity. So how much force should we apply to throw the ball?
3 games.
Okay. Same goes with hockey. We can say how much angle should force should give by the hockey stick, so it goes in the particular direction. And the third sport would be
Baseball or
pool ball.
basketball.
Yes.
It can be a baseball, basketball, and the hockey. As it all, we are using it unknowingly, the vector. So these 3 games can be played by using vector.
Okay.
Game needs
I can give a good example of this. Carrom board. Carrom board.
Yeah, ma'am, it can be because we have to calculate the angle.
And it also requires the magnitude and direction.
Yeah, direction as well as the force, the striker force which you are applying, both plays a major role to uh, take a goal, right?
Right.
Yes, ma'am. The striker and the angle from where we hit the striker to that.
So there
Same
are
goes
many
with the
plenty
pool.
of games. And even the version of the electronic version, that is digital version, gamification on mobiles and all, they also require quite a lot of vectors. I would also like to know about the tools which you have used to display the gamification here. You have shown that crossword puzzle, right? Using what you have made that?
Actually,
It's a website called Teachers Corner.
Site.
Which site?
Teachers Corner.
Okay, thank you.
Thank you, Surya and Mentor. The next number is R11.
Good morning to all.
My screen is visible. Good morning, everyone. Our project title, a study of some fundamental equation in fluid dynamics. These are our outline. Motion of fluid through conservation branch of science and engineering. Introduction.
Hello. You are keeping your mobile, I think, near to your system, computer system. There is an echo coming. Yeah, can you speak something, please?
Hello?
Yeah, now it's clear. Go ahead.
The main objective of project is on study of some fundamental equation of fluid dynamics, mathematical idea, to study the differential equation appears in fluid dynamics. Implementation, we study the equation of continuity and momentum. Description of fluid flow, there are two methods by which motion of fluid can be described, Eulerian method and Lagrangian method. The difference between Eulerian method and Lagrangian method. The Eulerian method we consider the fluid at fixed point. In Lagrangian method we consider the fluid at every point. Visualization. To visualize a fluid flow, timeline, path line, streamline, and streak line defined for each velocity field. The type of fluid. These are type of fluids. Now we will consider the derivation of continuity of equation. The derivation of continuity equation is nothing but the mathematical statement of principle of conservation of mass. The continuity equation, we can derive the continuity equation in a Cartesian coordinate. Here we can calculate the rate of mass flow in a parallel pipe. The rate of mass flow in x direction, we can calculate the mass of rate flow in x direction. The rate of mass of fluid entering inner left phase per unit time is given by equation number 1. Similarly, we can calculate the rate of mass of fluid leaving inner right phase per unit time in equation 2nd. Now, combining the both equation first and second, we will get the total gain in a mass per unit time due to the rate flow in a x direction given by equation number 3. Now, similarly, we can calculate the gain of mass per unit time due to the flow in a y direction by equation number 4. Similarly, in a direction z in equation number 5. Now, the total net gain in a fluid mass per unit time for a fluid along 3 coordinates x, y, and z, we will get equation number 6. As we know, the gain of mass in a mass of a fluid within the chosen element is given by equation number 7. Now, equating the equation number 6 and 7, we will get equation number 8. So the equation number 9 will be the equation for the continuity equation in Cartesian coordinate. There are two conditions in equation of continuity in Cartesian coordinate. First is for steady flow, where the density of a fluid is constant. So our equation become like equation number 10, and for incompressible fluid, rho is a constant. So we will get equation number 11. Now, the continuity equation in cylindrical coordinate gives the equation number 12, and the continuity equation in a spherical coordinate gives the equation number 30. Now, the derivation of differential momentum using the Newton's law of motion,
we will consider in this method, we will consider the force. There are two types of force on a system, body and surface. So we can calculate the fluid flow using derivation of differential momentum equation. The force on x direction is given by equation number 7. Similarly, the resultant force in a direction y and z are as 18 and 19. So the resultant force, combining the resultant force in x, y and z direction, the combining force with the body force del FB yield the resultant force del FB acting on a mass dm. So we will get equation number 20 and 21 and 22 respect to along x direction, y direction and z direction. Now the Ilius equation Ilius equation of motion. In Ilius equation of motion, we consider the ideal fluid flow in which the shearing stress are zero, means torques are zero, and the normal stress will be minus Q. Therefore, the general equation of motion reduced to equation number 23, 24, and 25 with respect to x direction, y direction, and z direction. The conclusion of the project is we devoted to study the description of fluid flow, some type of fluid flow, and governing equation of fluid flow dynamic in a particular and differential form of continuity equation. These are references that we have referred. We have referred these references for the study of this project. Thank you.
Hello.
Yes, sir.
You
Yes,
have
sir.
mentioned the word incompressible fluid.
Yes, sir.
Do you understand the meaning of it?
The incompressible fluid in which the fluid density of fluid will be constant. Hello, am I audible?
Your voice is again, there is a echo, I think. You kept your mobile with your computer system nearby.
Hello, now I am audible.
Yes, yes. Yeah, it's echo is again there. Bolo, you tell me.
So your question is to define incompressible fluid, yes?
Yes, yes.
The incompressible fluid is the density of fluid will be constant.
Okay. Okay. One more thing you have mentioned in your presentation is the Navier-Stokes equation or continuity equation, which is framed on,
Yes, sir.
you said it is framed on the law of conservation. Can you narrate those three laws of conservation which it uses?
So sorry, please repeat once again.
You said the continuity equation you are framing, okay, and it
Yes,
is
sir.
it is based on the laws of conservation, isn't it? You
Yes,
have
sir.
mentioned
Law
this.
of conservation of mass.
Yes. So this is actually using three laws of conservation. Can you just narrate what are those three laws of conservation?
First is law of conservation of mass.
That's
And
it.
second,
Okay. Okay. Thank you. I'm done.
Thank you. The next number is R12. R12.
Hello. Am I audible?
Yes, you're audible.
Yes, you are audible. Go ahead. Hello.
Is my PPT visible? Is my PPT visible?
No, it isn't visible.
Okay, I
Yes,
guess
it
there
is
is some
visible
lag.
now.
Our topic is applications of integral transform. This is the rough outline of our presentation. The transforms that will be discussed are Laplace and Fourier transform. Let's see Laplace transform and its applications first. This is the definition of Laplace transform. As you can see, here S is a complex number frequency parameter. Signals exist as a function of time, but in time domain, certain operations cannot be performed. The Laplace transform defines a new domain or the S-plane. The importance of S-plane is that it allows us to convert the differential equation of the time domain into a simple algebraic equation in the S domain. Thus, transforming the signal using Laplace transform makes it easier to perform certain operations on it. This is the application of Laplace transform, digital signal processing. Laplace transform can be used to solve differential equations. As you can see, this is a differential equation and Laplace transform is applied on it. Due to the properties of Laplace transform, we get a simple algebraic equation, and after solving it is simple, and we get some answer in the S domain. We apply the inverse Laplace transform, and we have solved the equation in terms of time. So we have basically solved the equation as we wanted. Control system is something which is used to control anything. It can be a thermostat used to control a domestic boiler, or large industrial control systems. You can see the equation, a simple example of mass spring damper system. The dynamics of the motion of this mass are functions of x, the displacement, the velocity, which is the derivative of displacement, and acceleration, which is the second derivative of displacement. We can solve it using Laplace transform. Data mining. These are the various techniques associated with data mining: classification, association, prediction, clustering, sequential patterns, and decision trees. Data mining is a process used by companies to turn raw data into useful information. Companies like Amazon, Flipkart get lots of data about the customers, but due to using data mining, they can convert it into some useful information. This information will help them in creating more effective market strategies and increasing sales. Laplace transform can be used to determine the prediction and analyze the step of knowledge in databases. Trend finding and data fitting is a very important application in machine learning, and it can be done using Laplace transforms. Laplace transform is used to characterize the output variable of the limit state function. The limit state function is based on the failure criteria for a specified case. Pipes burst at uncontrolled tearing point if the equivalent stress exceeds the flow stress. Thus, the LSF will be based on the new fracture criterion. 2/5 degree curvature formulae are employed to numerically approximate the Laplace transform. A mixture of skew normal distributions is then developed to recover the probability distribution of the LSF from the knowledge of its Laplace transform. By matching with the discrete values of the Laplace transform, the parameters of the mixture distribution are identified, and the probability distribution of LSF can be reconstructed. Thus, this proposed method can recover the probability distribution and estimate the failure probability for problems with low to high dimensional random inputs within a unified framework. The applications of data mining are financial analysis, telecommunication industry, intrusion detection, retail industry, higher education, energy industry, spatial data mining, and biological data analysis. The Fourier series of a periodic function of period 2L defined in the interval c to c plus 2L is as follows. The Fourier transform is also mentioned here, as you can see. The Fourier transform can be used to analyze non-periodic functions and random functions in classical mechanics. What it basically does is that it converts a time domain function into a frequency domain function. In voice recognition, the system can easily find out the user by analyzing its voice using Fourier transform. The voice frequencies are easy to identify than a time domain function voice. So frequency domain is useful here. Signal processing. Fourier transform can be used in signal processing. As I mentioned earlier, the time domain function is converted into a frequency domain function, and it is easier to process and perform applications on it. The Fourier transform can be used in military applications to perform reliable and safe communications. Using Fourier transform, we can decode the messages in a special way. This is approximation theory. As you can see, a square wave is approximated, sawtooth wave, triangle wave, and semicircle wave. These are approximator. Now, approximation theory. In mathematics, approximation theory is concerned with how functions can be approximated with simpler functions and characterizing the errors thereby. What is this? Functions can be easily approximated using Fourier series, and this is the infinite series from minus infinity to infinity, fn e ratio I n x. But a computer cannot compute it from minus infinity to infinity. Even humans can't do it. So we replace it with a finite one. So it is easier to calculate it from minus n to n. This is called partial sum. This is our original function fx is equal to x cube. For n is equal to 10, you can see that it is not very close to the original function. It is something different. But when we'll see n is equal to 50, it is approaching the original function. And as we increase the value of n, we'll get more and more close to the original. One problem of particular interest is the accuracy can be increased as we want if we increase the value of n. The applications of integral transform in mathematics as well as real life were discussed. In Laplace transform, the definition of scene and various applications in mining and data mining and machine learning were explored. It was discussed in detail about approximation theory and how it can be used to get a simplified polynomial. These are the references that we use. Thank you.
Sanket. Hello.
Yes.
Sanket, if I had a Fourier transform, what was the need of Laplace transform?
Laplace Fourier transform is used for certain specific cases, and Laplace transform is used for other cases.
Now, any example?
Sir, can I take this question?
Yes.
I'm in the same. So, for example, in signal processing, Laplace transform can change the magnitude of a signal, whereas Fourier transform cannot change the magnitude, but Laplace transform can change the magnitude as well as the oscillation part. So we can say that Fourier transform is a subset of Laplace transform.
Ishan, my suggestion is please see this theory once again.
Yeah.
Okay, once again, please see this theory, what you're saying. One is the subset of other, that is true. One is a special case of the other. But see this clearly and understand it so that you don't get confused in future on this.
Yeah.
Okay. Thank you.
Any more questions? Are there any more questions?
Saket, what was your number? Can you just repeat, please?
R12.
Okay.
Thank you, Saket and Ravi. Now we'll have a short break of 10 minutes. All the participants are requested to join the same link after the break. Thank you.
I hope all the judges have joined.
I'm there, sir.
Thank you. Yes, I, sir. I have sent in the link.
I'm also there, sir.
Yes, Sanskriti, we can start.
Okay, sir. Welcome back. So we may continue with the competition, and the next registration number is R14.
Is my screen visible?
Yes.
Yes, it is visible.
Okay. Uh, Good afternoon to all. The topic of our team is conformal mapping. Our course outline for the following is divided into 5 parts: abstract, mathematical idea, example, application, and conclusion. Our team registration ID is R014. So let's start with the introduction. The conformal mapping may be a crucial mathematical tool that will be used to solve varied physical and engineering issues in several fields, including electrostatics, hydraulics, Newtonian mechanics, and transformation optics. It is mainly used in solving terminal issues in electrical circuit. Conformal mapping has a disadvantage solving 3 or more terminals, which could be solved only by assumptions and approximations. The study represents a conformal mapping technique for multiple terminals. The plant technique helps promote the application of conformal mapping within the analysis of sensible issues. So, mathematical idea. Basically, conformal mapping is a part of complex variable, wherein the complex variable is divided into two parts, that is z-plane and w-plane. Z-plane mainly consists of x and y axis, which could be represented by z is equal to x plus iy, whereas x is the real part and y is the imaginary part, wherein w-plane is divided into two axes, that will be u and v axis considerably, which could be represented by w is equal to u plus iv. Basically, complex variable w is dependent on u and v, which is further dependent on x and y. Therefore, u and v is basically considered as dependent variable, whereas x and y is known as independent variable because it does not consider any other further variables. Practically, it is just impossible to map u, v, x, and y together on a single axis because the diagram then becomes a four-dimensional, which is practically not possible for us to draw. Therefore, we use the process of mapping. Basically, the process of mapping is converting the points, curves, or regions from z-plane to w-plane. And conformal mapping is that thing which keeps a record of angles and therefore the shapes of very small figures, but not necessarily we should know their size and curvature. It could be an infinitely small thing, but it's just not necessary that we know the size or curvature of the object that is given to us. For example, we have a question that find image of a rectangular region. We have just taken a two-dimensional rectangular region as an example, whose coordinates are given x is equal to 0, x is equal to 3, y equal to 0, and y equal to 2. And there's an equation of w given in terms of z, which is w is equal to z plus 1 plus I. And we are asked to sketch region. Basically, we have already seen that mapping is a process of converting from z-plane to w-plane. And our question is given coordinates of x and y, that is, of course, z-plane, because z's equation is z is equal to x plus iy. So basically, 4 coordinates are given, and we have plotted those 4 coordinates and found our required rectangular region. So we have to now convert it into w-plane. So we are given an equation which is w is equal to z plus 1 plus I. And since I've already mentioned that w is equal to u plus iv and z is equal to x plus iy, we are just substituting these values and separating the right hand side, that is z's equation, in the form of real and imaginary parts. So we get 2 equations, u and v, in terms of x and y, that is dependent variable in terms of independent variable. So then we have 4 coordinates, and we can find the new 4 coordinates of w plane using those 2 coordinates from equation number 2 and 3. And then basically we can sketch the region. And if we have to verify that our answer, what we have got, is right or wrong, we have to consider u in terms of x and v in terms of y. Basically, we have 2 coordinates of x, that is 3 and 0. So basic difference between them is 3. So we have got the breadth as 3. And when we look at the answer what we have obtained, we have u coordinates are 4 and 1, whose difference is even 3. So basically the breadth what we have got is what we have got is 3 itself. Similarly, the length will also remain the same. Now I hand over the applications to my fellow teammate.
The application of a conformal mapping is a cartograph. It is nothing but a study and practice of making map. The angle between the two curves that cross each other on the earth is the same as the in a mathematical sense. If two roads are crosses each other at 39 angle, then the maps show on a conformal projection across at 39 degrees 39 degree. The conformal mapping having many more applications like electrostatics, thermal conduction, heat conduction, and many more. It is basically used in electrical engineering and electromagnetic. The conclusion of a conformal mapping is the conformal mapping create its advantages in complex situations, specify in electromagnetic potential issue for general system. It's usually not possible to use method when the symmetry is broken. That's it. Thank you.
Hello.
Yes, sir.
Others, is the conformal mapping we use in the computer graphics?
Yes, sir, definitely. Wherever we have a diagrammatic representation, conformal mapping has its application.
How it is used? Do you know?
Basically in computer graphics as well. Like if I take example of my field, that is chemical engineering, we have like equipment designing. And in equipment designing, what we do is we make a simulation of the equipment. We try it on computer basis. So basically for that, the application uses also conformal mapping, which makes a replica of the original thing. Like including all the angle and precisions what we need, we use it in simulations.
Okay, others, this is not a question. This is just a suggestion I'm giving you. That you just find and read the technology which a mobile uses for zooming. Okay.
Yes, sir.
Now you know that simple 10 mm thickness mobile has zooming capacity of 50 times. Okay.
Yes, sir.
You will get a very interesting application of conformal mapping.
Yes, sir. It is actually image enhancement.
Yes, yes. So actually that is not done mechanically, but through this transformation only.
Yes, sir. The same application, basically same application also we use in mapping, because in maps, because basically if we consider roads and all, it's actually a very big area. But when we represent it in our phone, it's just basically a mere point. But it has that precision what our roads are constructed with.
Okay. Okay. Thank you. I'm done.
Thank you, sir. Any further questions?
Any more questions? So moving forward, the next number is R21. Is the screen visible?
Yes.
Okay. So good morning everyone. The topic of our presentation is coordinate gaming. And the unit registration number is e-MAPCO R021. Moving on to the introduction. Sometimes the simplest of the concepts can fascinate us completely. Who could have guessed that launching a red ball towards a tower of blocks can be so popular? Or a man running out to save his life from a demon to steal a treasure would be so popular. Toddlers to 90-year-olds have become enamored of this simple game, rooted in the mathematical concepts of vector calculus and projectile motion. The vector in the game development. Vector is a quantity that has both magnitude and direction in an n-dimensional space. Usually, a vector is represented by an arrow. But what are vectors useful for? Vectors can be used to describe all sorts of physical situations and more. In fact, a ball that is kicked in a football game can be situations where vectors are used to describe the force applied to the ball along with the direction where the force is applied. Same goes for a bullet shot from a gun. How is a vector defined in a game engine? In most game engines, you will find vector as a description of its three components, x, y, and z, as you can see in the diagram. But there would arise a question, why three components? Because a game is defined in a 3D world. So when we apply a force into the game object in our engine, we can apply in each arbitrary direction. Now moving on to the mathematical idea. The vector operations consist of the three mathematical ideas. Addition and subtraction of the vectors. The addition and the subtraction of the vectors cannot be done by the normal algebraic method of vector addition and subtraction. They require two laws, the triangle law of vector addition and subtraction as well as the parallelogram of vector addition and subtraction. Moving on to the dot product. The dot product can be used to find the angle between the two vectors. And the cross product. The cross product of the two vectors is another vector to the right angle of the both vectors. Linear interpolation, LERP. The linear interpolation is a mathematical operation to find an intermediate point between 2 points using a straight line. If the two known values are x1, y1 and x2, y2, then the value y for some point is y is equal to y1 plus x minus x1 into the slope of the line. This equation is very similar to the equation of the line, which is y is equal to mx plus c. Moving on to the line integral and surface integral. In vector calculus, the line integral of the vector is defined as an integral of some function along a curve. Surface integral. In calculus, the surface integral is defined as the generalization of the several integrals over the surface. Now my fellow mate will explain the implementation.
Okay, just now we saw that what is vector and some operations of vector. But how it is used in gaming application? Let's see. In implementation, here we took reference of very popular game Angry Birds to show how vector calculus means mathematics used to create this game. This game, Angry Bird could be categorized as a type of micro world game. Here we use trigonometry, vector calculus, and projectile motion to create this game. In Angry Bird, the slingshot exerts a force onto the bird at a certain angle that sends a bird into motion until the tower of peaks exert an equal and opposite force to stop the flight of bird. In next slide, we see the parabola and Angry Bird and projectile motion. In this, we see that the Angry parabola is a result of two factors, the slingshot force and its angle. Here we see the chart. In this, we see that slingshot force with the help of polar coordinates and some angle. In next slide, we see some physics where we used in kinematic equation to show how it works. Here are two kinematic equations. By using last equation and the verification, we can take the angry parabola in standard form. Then it comes to outcomes. Gamification is growing more popular in last few years. We all play games and enjoy the time spent doing it. From this survey, we conclude that vector calculus is very useful in online gaming application. Using Angry Bird and some many other applications, other games, we help us explore mathematical concepts in way that have direct appeal. In next slide, we see some references and books where we used in these presentations. Thank you.
Hi, Rachna here.
Yes, ma'am.
Other than what you have used here, vectors, can you list any two things, mathematical topics which are used in this Angry Birds?
Yes, ma'am. In Angry Birds, two of the mathematical concepts are used, that is projectile motion.
Sorry, come again.
And parabola. Projectile motion and circular trigonometry, which includes parabola.
Okay.
Any more questions?
Sanskrit, can you unmute Desai sir? Alaganda Desai sir. Nitish, unmute Desai sir.
Sir, we can't unmute any other participant.
Desai sir, you can unmute yourself. If there is no question, then we'll move forward. But I think Desai sir has some question.
बताइए मैं पूछती हूँ.
Okay, ma'am.
Just a second, I am putting him online.
Complex number and vector.
So come again.
Differentiate between the complex number and vector.
Can you get his question?
No, ma'am. Can you repeat?
Sir, वापस बताइए आपका question.
Difference how we use the vector in complex or complex as a vector.
Okay.
Just basic knowledge.
Yes, how can we use complex numbers as a vector or vectors as a complex number? Can you give the basic difference? This is what sir is asking. This is a question
Yes, ma'am.
from Desai sir.
Ma'am, can you repeat it again?
Yes, so sir wanted to ask you that how the complex number can be represented as vectors or vectors can be represented into complex number, or is there any difference why we use these two different notations?
I'll reframe this question for you. Okay. Is there any relation between the complex numbers and vectors?
Okay, sir.
Yeah. Okay, fine. Is there any other question? Okay, Sanskriti, then we'll move on the next project. So go for the next project.
Okay, sir. So the next number is R23. audible, ma'am? Hello? Yes, you're audible.
Yes, yes.
Is my screen visible? Yes,
Yeah.
it is visible. Okay. So, good afternoon to one and all. I am here to present on a topic, roles of integral transform for better civilization and facilities. My registration ID is EMAPCO R023. So, the contents of my project are here: integral transform, Laplace transform in control system, automobile speed controller, that is cruise control system. Now, the objective of my projects are here: to control speed of automobiles, to avoid the accidents on roads, to explore features and functionality, to initiate lowest wireless technology, to less manpower, to get better facilities, way to digital world for better civilization. Now, let's first see what is integral transform. The motivation behind integral transforms is easy to understand. There are many classes of problems that are difficult to solve or at least quite unlikely algebraically in their original representation. An integral transform maps an equation from its original domain into another domain. Manipulating and solving the equation in the target domain can be much easier than manipulation and solution in the original domain. The solution is then mapped back to the original domain with the inverse of the integral transform. There are several types of integral transform. From one of the is Laplace transform. Laplace transform converts a function of real variable to the function of complex variable. Here you see in this slide, if we give an input to the transfer function, then we get as output as a CS function. That is, if we give a time domain, then we get a as domain. Now there are several types of integral transform. From those, one of the is from those one of the is in there is now there are several types of integral transform. From those, one of the is Laplace transform. So here we see the various applications as given. Among them, my project is on Laplace transform in control system. Now, one of the application is automobile speed controller. Firstly, I used cruise control system to maintain the speed of vehicles. The model of the cruise control system is relatively simple. If the inertia of the vehicles is neglected and it is assumed that friction is what is opposing the motion of the car, then the problem is reduced to the simple mass and damper system. By this, I find that the speed of vehicles can be changes as per we put our desired value in the related equations. And now, as per my objective of project, I try to use second method of speed controller. Now, let's see the concept of methodology. Simple. Nowadays, people drive very fast, accidents occur frequently, and there is a loss of property and life. In order to avoid such kind of accidents, to alert the drivers and to control their vehicle speed, RF technology is being used. The main objective is to design a smart display controller meant for vehicle speed controller and monitoring of zones, which can be run on the embedded system. Smart display and controller can be custom designed to fit into a vehicle's dashboard and displays information on the vehicles. The project is comprises of two separate modules. First is zone status transmitter unit and receiver, that is speed display and control unit. Once the information is received from the zones, the vehicle's embedded unit automatically alters the driver to reduce the speed according to the zones. It waits for few seconds, and otherwise vehicle's SDC unit automatically reduces the speed. In my proposed project, I used transmitter and receiver to communicate the signals in transmitter section. I used micro switches as input signals. These signals are encoded by the encoder and later encoded signals are transmitted through the transmitter. In general, the speed of the automobile is varied according to the accelerator pedal position. Here you see
according to the here is pedal position sensor. So the variation in the pedal position is fed to the electronic control system, that is ECU. ECU determines the position of the throttle based on the accelerator pedal position and the inputs received from the other sensors. Adjustment of the throttle position causes the change in the variation of automobile speed. Here is the hardware scheme of normal controller system. Here we see, and whereas in the proposed automatic vehicle speed controller, model accelerator pedal position is given to the microcontroller unit. Here see, pedal position sensor given to the microcontroller unit, and then it is fed to the electronic control unit. If the automobile is in active mode, microcontroller transfers the manipulated pedal position to the ECU that will not increase the automobile speed greater than the maximum speed specified in the data packet. Then, in the model, as per of my project, the transmitter is to be fixed to the top of the pole at the location where speed of the automobile needs to control. The job of the transmitter is to transmit the frames that specify the maximum speed and the time for which the speed limitations must be implemented. Whenever the vehicle passes nearby transmitter, receivers in the automobile detects the frame and gets ready to receive the frame. After completion of receiving the frame, it generates interrupt to microcontroller. Here interruption occurs, then the microcontroller processes the frame received from the wireless module and then enters into the active mode. So in this way, speed of automobiles in this way, this firstly microcontroller unit, then okay. In this way, speed of automobile should be controlled. And my further objective is that to make car as a robots which transmits or receives waves by which the location be displayed, and it could be totally controlled by some digital gadgets. Further, for these projects have to collaborate too many systems that are firstly have to embed wireless module. Second, wireless remote to decrease or increase the speed. And third one is speed zones. According to my research, I think need to be set up, I think 2 speed zones. Then after this, I conclude to my project. So now my conclusion of this project is that the whole system idea can be implemented for the purpose of short distance online delivery. And we all know that and now we all know about the Atal Tunnel, currently inaugurated by Honorable our Prime Minister Narendra Modi. So for better, I think so for better safety, this system can be used. And nowadays, the government assigned a new project of same that is forming a tunnel Srinagar and Jammu and Kashmir. So if we use such systems while construction, then may it takes a secure and luxurious life. Here is conclusion, and here we see the model of my project that is going in my mind mapping. Here a robot also turns into a car. So that car is used for online delivery and so many purposes. So now, thank you.
Hi, Reshma here.
Hello, ma'am.
Yeah, you have mentioned integral differential equation. What is it?
What, ma'am?
Integral differential equation. What do you mean by integral differential equations?
Ma'am, actually, integral differential equation is an equation that involves both integral and derivatives of a function to solve any concept or any formula.
Okay.
It actually is a collaboration of integral and derivatives.
Okay.
Thank you, ma'am.
So I have one more question. Do you really think that integral transform will be really very helpful in better civilization?
Um, it actually, ma'am, it is helpful. Um, so nowadays, we see, according to my research, I see a format of in 2011 there are so many accidents occurs, and the lives of so many people are get spoiled. So if we use this concept to make our industrial civilization better, uh, or to give more facilities to our citizens, then it's okay. So, it's now better for civilization. And nowadays we see because of COVID-19, everything is now online. Our session is also now online. So no one citizens can dare to go market and give purchase anything. So they order online, but it is also harm for the peoples or other citizens. So if we use such a concept or such a digital way to for an online delivery, then it does not harm to any person. It works only in a digital way, only by robots, and it also helps to keep distance from person to person.
Okay.
Okay, thank you, ma'am.
Hello, Shipra.
Yes, sir.
My question is very basic.
Yes.
Let us tell me what the condition of Laplace transform. When you apply and how you use that condition in the control.
Okay, sir. So actually, Laplace transform is mostly used to solve, as we know, integral derivation to a algorithmic derivation. But in control system, we use it. There are so many ways, as I told the cruise control system. In that cruise control system, we there are so many ways to solve the equations, such as by applying a Newton's second law, and this then system equations are v mv plus bv is equals to u, and then further it makes to I think y is equals to u. If we puts the values or suppose regarding my project, if I put a weight of vehicle and then desired speed, then after putting the values in the further state space model formulas, then we get the desired solution that helps us to maintain the speed of the vehicles. So that's why we use to Laplace transform for equation. And I don't think that for by normal equations we get such type of solutions. As we know, Laplace transform is um, digital is method to convert the equation very easier. So
Okay.
would you have any other questions, sir? So actually, it plays an important role in control theory. It appears in the description of linear time invariant system, where it changes the convolutional operators into multiplication operators and allows to define the transfer function of the system. That's why Laplace transform is more suitable to use in control system. And mainly, it is a main application of Laplace transform. Is there any question, ma'am?
Go ahead.
Thank you, Shipra. And the next number is R27.
Good afternoon to respected members of jury present over here. Today, we will be discussing about Fourier transform and its application. In mathematics, a Fourier transform is a mathematical transform that decomposes a function, often a function of a time or a signal, into its constituent frequency. Moving toward the basic agenda of our presentation is the first one itself is introduction. What is Fourier transform? And we'll also learn the various application of it which is being used in our daily life, and the last one is conclusion. This topic we have choose or get this idea because as a second year student we have this as a part of our syllabus, and it is one of the most important application that is used in our day-to-day life, like image compression and image processing. Further moving, using with the help of a pie chart, we can understand some basic difference between Fourier series and Fourier transform. Like we have so further we will be learning with the difference between a Fourier series versus Fourier transform. We have in period signal and continuous time we use Fourier series. In periodic signal and discrete time we use discrete Fourier series. In aperiodic signal and discrete time we use discrete Fourier transform. In aperiodic signal and continuous time we use Fourier transform. You can see over there in the picture. Now let's proceed further and let's quickly dive into our main topic, Fourier transform. So talking about Fourier transform, the formula of Fourier transform is Fourier transform of S equals to 1 upon 2 pi integration minus infinity to infinity function of x into e raised to I minus isx dx, which is the formula of Fourier transform, which is a Fourier transform of function of x, which is a piecewise continuous from minus infinity to infinity. Now let us understand further with the help of a diagram, which is displayed below. So here you can see a sound source of true frequency of 3000 Hz and 5000 Hz respectively, and it is recorded through mic, and then it is displayed into a time domain signal graph. In amplitude versus time graph, the signal is continuous but aperiodic. So when the Fourier transform is applied to it to convert into frequency domain, the amplitude versus frequency graph contain two peak area for 3000 Hz and 5000 Hz respectively. So now moving towards the important part, which is called as properties and types of Fourier transform of our PPT. Now there are many properties of Fourier transform, but the major one which we are going to be using in the application of Fourier transform are being linear shifting, linear property, shifting property, and change of scale property. Also, there are different types of transform known as fast Fourier transform and discrete Fourier transform. So you can see that in the screen: linear property, shifting property, change of scale property, fast Fourier transform, and discrete Fourier transform. Now we'll be learning about the application by my teammate.
Hello. So we learned about what is Fourier transformation. Now we will see about what are the applications of the Fourier transform. The very first application is image processing. As we can see on the screen, there is an original image taken by the core galaxy of Hubble telescope by the NASA. So we can see that the original image is blurred due to this starlight and all about the limitation of the telescope. So we need a clear picture so that we can imagine what is outside in the space. So we use Fourier transform for that. The image in the Fourier domain is decomposed into the sinusoidal components that are for sine waves and cosine waves. So it becomes very easy to examine or process certain frequencies of the image. Thus, we can improvise and influence the geometric structure in the spatial domain. So the image can be clear and realistic to us. The very next application based on the Fourier transformation is the image compression. Image compression comes under image processing. Image processing has many other components such as image reconstruction, image processing, and also the image compression inside it. As we can see on the screen. Next slide, please. Hello, Purva, can I present the PPT? So as you can see on can I present the PPT?
Is the PPT visible?
Yes, it is visible.
Yeah. Okay, so as we can see on the screen, there are two images on the left hand side and on the right hand side. The first image is of 8.9 MB memory size, and the other image is of 68 KB. So as we know that we need to upload some images on the website, and the website suggests that it should not be greater than 1 MB or it should not be greater than 2 MB. So such images cannot be updated. So we need to compress those images into some lower memory size, and the image quality should be decompressed. So we use fast Fourier transformation in the image compression algorithm. So the image is divided into 8 by 8 or 16 by 16 pixels, and the 2D discrete cosine transform is computed for the each block. The DCT coefficients are quantized, coded, and transmitted according to the image we need to compress. So the next application is signal processing. The Fourier transform is extensively used in the field of signal processing. In fact, the Fourier transform is probably the most important tool for analyzing signals in the entire field. As we can see on the screen, there is a random waveform coming from the left hand side, and we are extracting the useful information from the right hand side. We can take an example of some military examples that some of them share the image wherein some useful information is stored in it. So by using signal processing, we can extract those important data and can be send the images to other people. So the impulse in time can be thought as of infinite sum of sinusoids at every possible frequency. So we know that there are many waves which interfere at a position, and by superposition theorem, the sum of the responses to each frequency are noted as the result. So further, it is used in MRI. MRI stands for magnetic resonance imaging, where we can check full body internal checkup. Radar in military applications, there are electromagnetic radiations coming out, so we can use it for military purposes. Crystallography for study the crystal structure or lattice structure of a material, and cell phones we can use for social networking or social communication and other ways. So the very next application is circuit analysis. The Fourier transform is also very useful for circuit analysis. We get to know every linear resistive circuit methods by replacing resistance with impedance. The use of Fourier transform for circuit analysis for LTI circuits is the basis of most analog filter design method. As we can see on the screen, there is a diagram which has an input small x of t into the electric circuit, which consists of resistors, inductors, or many much more sub components, and we need the output in the form of y of t. But that's very difficult to take out the signals. So we use Fourier transform, convert it into the frequency modulation JW, and then we get the output, and the output is restored again by using the inverse Fourier transformation. The circuit analysis has a further application as AC to DC conversion. See, as we can see on the screen, since every continuous analog signal has to be converted to the DC signal, using AC to DC converter, we can use all this. This way, we can obtain also the discrete signal utilizing the Fourier transformation. As we can see, there is a graph on the right hand side which consists of an f of x. So the f of x has many waves coming from it. As you can see, it's loading. So there is a formula for Fourier transform when there are many of such waves of sine curves, sine waves or cosine waves. It is then converted into the DC signal, and we get f dash of x. Also, we can see the another image on the downside that a person is speaking and it's recorded through a microphone. Thus, it is recorded through the microphone. We get the electric signal, which is then passed to the analog to digital converter, and the value is stored in the digital storage. Hence, we can say that the Fourier transform is used in many wider applications. Hence, Fourier transform is ranging from experimental instruments to rigorous mathematical analysis techniques. Thanks to the modern developments, we can use it in electronics department, telecommunication, computer graphics, and much more such areas. We have studied about the image processing compression which will be used in some of the examples. I can say that WhatsApp uses image compression. If one user sends to the another person, the image is being compressed. Signal processing can be used for devices for communication. Circuit analysis is used, and AC to DC conversion for the day-to-day life for taking the electricity and all. So we conclude here, and these are some of the references shown on the screen. Thank you.
Okay, I have a question. Is there any relation between the image processing and signal processing? Hello, am I audible?
Yes, sir.
Yeah.
So question, repeat please.
So my question is there any relation between the signal processing and image processing?
Actually, image processing is done by using the Fourier transform in the way such that they are it is done by using the pixels, and if we decrease the pixel, the image is automatically processed according to it. Also, the Fourier transform properties are used for the image processing, which is the linear property, shifting property for some of the applications. Also, we can use change of scale property for the image to be compressed, enlarged, or to be make it small. And for signal processing, as we all know that it decomposes the time signal into the frequency modulation. So we can use for it some of the sound tones and also for the signal processing for the same.
So I got confused now because my question was, is there any relation between the signal processing and image processing? Okay, the next
Do you
question is,
understand the question? G,
Yes, sir.
do you understand the question? What sir is asking you?
Yes,
They
a
want the
relation
difference
between
between
the
signal and image.
yeah, actually in image processing, image means the where there is a color intensities are used for taking the graph method, and when there is color intensities are high, frequency of that position on the pixel would be greater. So by using that means the both applications are similar to it. That one uses the Fourier transformation for the color intensity, taking the frequencies of the color intensities, and the other one uses actually the signal uses the sound modulation, and other also the due to the we get the sine or cosine curves. So by that it's similar between them.
okay. The other you mentioned about the discrete Fourier transform, DFT and FFT. So what is the difference between DFT and FFT? I hope you got my question. What is the difference between the DFT and FFT?
Once repeat again, sir.
What is the difference between DFT and FFT? Fast Fourier transform and discrete Fourier transform.
Okay, sir.
Hello, sir. Myself, Darshan, from this team, like to add on this point.
Yes, continue.
Discrete Fourier transform is a discrete version of Fourier transform that converts the discrete signal from time domain to frequency domain. And fast Fourier transform is an effective algorithm to calculate DFT.
Okay. So that means DFT and FFT are same.
Yes, it can say it is a subset.
DFT is subset of FFT or FFT is subset of DFT?
DFT is a subset of FFT because it is used, FFT is used for calculating the DFT. Means DFT is a subset of FFT.
Okay, so DFT is a subset of FFT. What else you can do using FFT other than DFT? Okay, no problem. Thank you. Okay, if anybody has a question, please ask.
Go ahead.
So thank you, sir, for asking us a question. We will surely will get a research on DFT and FFT once again, and we'll take a deep research on it. Thank you, sir, very much.
Okay.
Sanskriti, go ahead.
Okay. The next number is R28.
Namaskar to all the attendees. We the team R28 from and our topic is partial differentiation. Before moving to the partial differentiation, let's have a view about total differentiation. For a function of two or more independent variables, the total differential of the function is a sum over all of the independent variables of a particular derivative of the function with respect to the variable times the total differential of that variable. Moving forward, differential equation is a mathematical equation that relates some functions with its derivatives. It's broader divided into two parts, ordinary differential equation and the partial differential equation. Now, what's partial differential equation? Let's u be the function of minimum two independent variables. Then equation involves u, its independent variables and the partial derivatives is known as partial differential equation. Moving forward to, now comes the question, what's the partial differentiation is? A partial differentiation of a function of a several variables is derivative with respect to one of those variables with other held constant. Moving forward to explicit and implicit functions, in the simple words, we can say that suppose y is expressed in terms of x. Y is a function and it's been expressed in terms of x, then y is called explicit function. But whereas if x and y are so mixed up and you can't express y in terms of x, then y is called implicit function. Here are the example of implicit and explicit functions with their graphs. Moving forward, Euler's theorem. Euler's theorem states that if a function f of ai, where I is a natural number, is homogeneous to the degree n, then such functions can be written in a form of its partial derivatives. As you can see on the screen, the below is the example where x and y are the variables. Now comes Jacobian. Jacobian states that if xi be a function of n numbers of independent variables with another n numbers of variables, then determinant is called Jacobian. For example, you can see the case 2, 2D case where x and y are independent variables with respect to u and v, then it's called as Jacobian of x and y with respect to u and v. Same goes with 3D one, where x and y, x, y, z are the three independent variables which can be expressed in terms of three another independent variable, u, v, and w. Now, moving towards the application of partial differentiation in our daily life, I would like to first mention that while going through the study of partial differentiation, we came across many beautiful different applications of it. From that, we pick the two basic applications on which the theories and formulas are based: heat equation and the wave equation. Whenever energy is being supplied to any material, it's vibrate at molecular level. That vibration creates emits an energy. That energy is in form of wave or radiation. And heat is one of the type of radiation. Now, I'm going to explain you how beautifully partial differentiation resembles with wave equation. The wave equation is a linear second order partial differential equation which describes the propagation of oscillation at a fixed speed in some quantity y, where v is the velocity of the wave. You can see the equation on the screen. This wave equation is the base for formation of wind instruments and the large auditoriums and opera houses. Now, one-dimensional heat equation. From the childhood, we have learned that if we have a thin bar conducting a bar, and if we start heating from one end, the heat will field on the next end. For that, we have to consider that the cross-section area is constant and the material is homogeneous material, which is oriented along the x-axis and is perfectly isolated laterally, so that heat flows only in the x direction. Then it depends on x and time t, and heat equation becomes one-dimensional heat equation. The below two images shows that how the temperature varies with the distance. But if we reduce the distance at a very small, if we reduce the distance, we can say that the temperature T1 will be approximately equals to T2. And the image on the right side shows that how controlled heat can be used to form and repair the objects rather than destroying it. Now, last but not the least, we would like to thank the organizing committee for allowing us to present our presentation. As there was a time limit, so we are just briefed through the we are given the sponsor briefings to the topics. And here even we will like to thank for helping us to explore how interesting maths will become if we try to implement in our daily life. We also encountered that fluid mechanics, heat and mass transfer and electromagnetic theory and many more are all modeled by partial differential equations. Even one of our team member found that it's been applied in cooking, testing taste of the food. You can improve or decrease the taste of the food, like where there are the variables are where the variables are oil, spices, and vegetables. And if you keep rest of spices and vegetables as constant and oil as variable, then you can change the taste of the food. Thank you.
Hello.
Yes, sir.
Ajit, one small question, simple, basic. What is the difference between the ordinary and partial differentiation? Differential equation, sorry. Ordinary differential equation and partial differential equation. Hello. Hello, Jit.
Yes. Yes, sir.
What are the difference between ordinary differential equation and partial differential equation? Because I mentioned very nicely the partial differential equation.
Yeah, sir. The ordinary differential equation is also known as linear differential equation, where there is only differentiation or what we can say like I'm not able to frame it like a proper way.
Okay, thank you. No problem. Now the question is, in heat flow equation, you mentioned the heat flow equation. So how many independent variables and how many dependent variables in that? Let us see, if you want, you can open and see your PPT. Here you mentioned the heat flow equation.
Yeah.
So which are the dependent variable and which are the independent variables?
So the independent variable would be the distance x and the time t.
Repeat again, please.
In that heat equation, the distance x and the time t will be the independent variables.
And what are the dependent?
The rate of change, the function u will be the dependent one.
What is u represents in your equation? Okay, thank you.
Okay, then the next number is R29.
Good afternoon to all sirs and teachers. Can I audible?
Yes.
Yes, you're audible.
And my PPT was just a second, sir. Sir, my PPT was audio. सर मेरी PPT दिख रही है?
हाँ चलो जानो.
Our
Go ahead,
registration
go ahead.
number is R29, and our topic is calculus. And these are the content in which we discuss about calculus. Calculus is the mathematical study of continuous changes in which two major branches, differential calculus and integral calculus. Differential calculus is the concern with the problem of finding the rate of change of function with respect to the other variable. Integral calculus is the study of integrals, and it's mostly useful to calculate the function from its derivative and also to calculate area under the curves. Now, there are some questions arise like how to calculate instantaneous speed and how to same as area under the curves. At that time, our Indian astronomers Brahma Bhaskaracharya gave the theory of instantaneous motion of planet, and also the other astronomers and mathematicians like Madhava and Deva gave us the arithmetic geometric series, notation of integration, and so many things in 15th century. And the modern calculus is developed by Newton and Leibniz in 17th century. Definitely, we can discuss so many things in literature about calculus. Obviously, there are some use of calculus in our daily life. Like every 10 year, every 10 year later, the data of population of our country will be given to us. This only to possible by using calculus. These are some formulas used to find some population size of population of our country. Similarly, it is useful in mechanics when a force apply on any body like a ball or a car, etc. After that, it will be accelerate, and to find acceleration, we need to derivate. We needs derivative of velocity or second derivative of spatial position. Same as calculus are used in sports like basketball, in which we can derive equation for finding the arc length of the basketball throw. These are some calculation for it. It also beneficial for wind power station to derive the equation for calculating how much power will generate. By using method of calculus, we solve some problems of astronomy, physics, problems in astronomy, physics, and real life, etc. In astronomy, astronomers use it to finding the motion of planets and spaceships, etc. Now, we take some formal statement of the problem in which we describe how to derive equation for total increasing velocity of rocket and thrust force of rocket by using integral and differential calculus respectively. Similar way, Laplace transformation is used to solve the problem of engineering and branch of physics, other branches of physics, so on. By applying Laplace transformation in LCR circuit to find the change in capacitor at any time t besides 0. After calculation, we get the result in the form of graph. At the last but not the least, we all suffering from the global problem COVID-19. We know that the data of cases of COVID-19 in India or other country, these data was forming by using calculus and SR models. We can get the graph of cases of COVID-19. For all this work, we conclude that is the legs of calculus is the legs of our body of mathematics. Calculus is only one branch that give us a real life application, and differential and integration are powerful tool to solve the problems. These are our references. from we get the information. And thank you.
Hello.
Yes, sir.
Shailen, yeah, this is Avinash Pandey here. In your first slide of your PPT, you have mentioned fundamental theorem. So, would you elaborate that? What is a fundamental theorem of calculus?
Sorry, sir. Your voice is not clear.
Hello. Hello. Am I audible?
Yes, sir.
Okay. In your first slide, you have mentioned calculus, okay, and fundamental theorem. So, what is the fundamental theorem of calculus? You can open your first PPT. I mean, first slide.
Hello, sir.
Hello. Yes.
I'm a teammate of Shailendra.
Yes.
Differential and integration both are included in fundamental theorem of calculus. Fundamental theorem of calculus is different two branches. It is a differential and integration. So all of a differential and integration concept is included in fundamental theorem of calculus.
Now, what is that? What are the theorem states? Do you know the fundamental theorem?
Okay. Is it
Precisely.
reflecting in first PPT? Right now, whatever is you're showing the first slide, the fundamental theorem of calculus statement is available somewhere here.
Sir, it is there, fundamental theorem.
Yes, sir. Okay, fine.
Okay, one more small question. Keep the same. So in calculus, you mentioned only two, differential calculus and integral calculus. Other than these two, is there any calculus content? Do you know? These two are only
Sir.
called as calculus.
Okay. Sir, many types of calculus is like limit, vectors, also include in calculus, but our choose a differential and integrate calculus.
So vector calculus is one part of the calculus, correct?
Yes.
So other than these two, a part of calculus you are telling, but other than these two, is there any calculus containing the terms? For example, do you tell me? Because you explain nicely calculus, no problem.
Sir, please repeat your question.
Other than differential and integral calculus, is there any other terms containing in the calculus? Or only these two are known as a calculus? Okay, thank you. Sir, go ahead.
And now the final presentation for today's competition is R30.
Is R30 ready? Participants from R30.
Sanskriti, let us check.
Sir, we have some technical issue.
Okay, go ahead.
Okay, no problem.
No problem.
चल युवामा.
Sir, am I audible?
Yeah.
Yes, yes.
Good afternoon to all. In numerical analysis, we will presenting about numerical methods and their applications. When analytical solution of mathematical problem is possible, but it is time consuming and having an error of approximation. That's why we need numerical methods for close to solution of hard problems. Here we will discuss about 4 methods, but here confusion is that which method is for better approximation. By the rate of convergence, if the rate of convergence of method is high, then fewer iterations are needed for the solution. Moving to bisection method. Bisection method is an approximation method to find the root of the given equation by repeatedly dividing the interval. By the graph, a few steps of the bisection method applied it over the starting range even B1. Here, the bigger red dot indicates root of the function. This method is linearly convergent. Here, advantages and limitations of bisection method. The biggest disadvantages of bisection method is slow rate of convergence. Now moving to second method, which is false position method, and it is also called as regular falsy method. Bisection method and false position method are quite similar. The only difference is that the bisection method, both limits of the interval have to change. By the graph, as we increase the number of iterations, we get more accurate values of the root. Similar as bisection method, this method is also linearly convergent. Here are the advantages and limitations of bisection method. Now moving to another method, which is Newton-Raphson method. This method is found for better approximation to the root of the real valued function. By the graph, the Newton-Raphson method works by taking a tangent line at the value of the function at the initial cases and seeing where that tangent line crosses the x-axis. Newton-Raphson method may or may not be converged. If it is converged, then its rate of convergence is 2. The biggest advantages of Newton-Raphson method is high rate of convergence. Moving to another method, fixed point iteration method. In fixed point iteration method, iteration converge if mod g dash of x is less than 1 and diverge if mod g dash of x is greater than or equal to 1. Here are the advantages and limitations of fixed point iteration method. There are so many applications used in real life. Here are we indicate some. First, bisection method for electrical engineering. Bisection method is used in many fields of engineering, but we shown in electrical engineering in thermistors to determine the value of resistance. The relation between temperature and resistance is given here. A and B are indicate RL and RU
After doing some iteration, we get value of the resistance with minimum absolute error. Second, Newton-Raphson method in chemical engineering. In chemical engineering, the height of oil is found by Newton-Raphson method. For that, we need derivative of the function and initial approximation. That is in the presentation. Here is the example of iteration method. We take two value of phi of x. For one, the value of phi of x, the function is converged, and for the two, the value of phi of x, the function is diverged. Some application of numerical analysis in day-to-day life. It is used in estimation of ocean currents, weather prediction, network simulation, etc. After all this work, we conclude that different numerical methods have different rate of convergence, and it is very important in solution of polynomial and transcendental equations. Here are some references. Thank you, sir. Thank you, ma'am.
Hello.
Yes, ma'am. Yes, sir.
Hello, I'm KP Patil calling. I just want to ask you one simple question. You have mentioned that in the theoretical part that real valued function, I just want to know all these numerical methods which you have explained by 16 method, Newton's-Raphson method, are they going to give all the roots or all the solutions, and are all the solutions real solutions? You got my point?
Yes, sir.
You are solving the equation. The explanation is fine, but the solution which we get, are these all real, or is there any? Hello?
Can you
Are we?
repeat this question again?
Yes, sir, it's repeating.
Yes, see the numerical methods, using numerical methods, whichever you have stated, you are getting a solution. My question is, are you getting all possible solutions, and are the all possible solutions real solutions?
Yes, sir.
You get all the solution? Yes, sir, means for both you are having the answer yes?
Yes, sir.
Okay.
Means you will get all the solutions are real only.
Yes, sir. It is real.
But if it is cubic equation, then all real you'll get. Cubic polynomial equation. Just to mention one equation, you give an x cube something in the presentation. So all three roots are will get as a real. Are you sure?
Sir, I'm not sure.
Oh, okay. Now, which equations you are solving by using these methods?
Transcendental and algebraic.
What is the meaning of transcendental?
So, log trigonometric exponential equation.
Yeah. So, do you know any other methods for solving simultaneous equations? As numerical method you selected, numerical analysis is a very big one.
Yes, sir. There is second method.
Pardon?
Muller method. Yes, sir.
No, solving simultaneous equations.
Sorry, sir. No idea about which method.
Okay, go ahead. Sir, continue.
Hello. Hello.
Okay.
Vishwa. Hello.
Yes, sir.
You are a computer student?
No, sir. We are from BSc with mathematics.
Okay. Okay. Why you have taken this topic, numerical analysis?
Okay, sir. We are studied at numerical analysis in our SY, and we want to know about more.
Okay.
That's why.
Okay. Fine. Fine.
Okay, sir.
Thank you.
Hello.
Yes,
One
sir.
last question. This is Avinash Kamble.
Okay, sir.
Fine. You have chosen a numerical analysis, and you have said that by using bisection method or so many
Huh.
methods, you are solving an equation. So
Yes, sir.
after getting us, I mean, after solving this equation by using numerical methods, any one of the method, are you getting the exact solution or approximate solution?
Approximate solution, sir.
Done. I'm done.
Okay, sir. Thank you.
Sanskruti.
Any more questions, judges?
Okay, Sanskruti, go ahead.
Okay. Thank you everyone for attending this session. Now I would give the call to Usha ma'am for the vote of thanks.
Thank you, Sanskriti. I, Usha Bag, on behalf of EMTSI, first of all extend my most sincere thanks to our guest of honor, Dr. Suresh Ukrandhe sir, who spared time from his busy schedule to grace the occasion. I would also like to sincerely thank our sponsor, Professor Satish Kumar Varot sir, for having sponsored our project e-MAPCO 2020. A special thanks to all the judges who have devoted time for judging all the projects in round 1 and round 2 of e-MAPCO 2020. An event like this cannot happen overnight. The wheel started rolling weeks ago. It requires planning and a bird eye for details. We have been fortunate enough to backed by a team of very proactive and dedicated members of EMTSI for their numerous cooperation in organizing e-MAPCO 2020. I would also like to thank the volunteers who have worked behind the scene to make this event happen. Our technical arrangement team, execution team, publicity team, registration team. This event would not have been smoothly done as it would not have been all of you who had put in the long hours. Last but not the least, a very big thank you to each one of the participants and their mentors, without whom this event would not have been possible. We value you and your movement, every moment that you have stayed in this temple of learning. I cannot thank everyone enough for their involvement and their willingness to take on the completion of tasks beyond their comfort zone. Hope to meet you all soon with another such event organized by EMTSI. Thank you. Thank you.
Thank you so much, ma'am. Once again, thank you very much to all those who assembled here. This program is a huge success, and the credit goes to all the participants as well as the members, faculties, and our chief guest of honor, who worked extremely hard for this success. Thank you so much for your presence.
Sir, you are unmute करो sir. दसरे sir. हाँ.
Yes, sir. Yes, sir. Okay. So I hope we are done. We are done. Then we can stop here.
Yes.
Thank you, everybody. So thanks a lot.
Thank you, sir.
Thank you, participants.
Thank you, sir, for a good achievement which we have done today. Great success to all. And what I wanted to just make a point, all the participants who have today given their presentation, they are one way or the other winner of all this. No doubt who is the first, who is second, but really good efforts from all. and teamwork has proved that things can be done even if we are not meeting on online. The things can be done. Thanks to all, sir, on all your cooperation. Good day.
So thanks to the teamwork and the Suresh sir taken a lot of effort for doing this. And participants are also good because I saw 1, 2, 3, 4, 5, 6, 7 participants. Very nicely explain the mathematical part and but basic required for them.
Sanskriti, Nitish, you can stop live now. Okay.
Okay.
Okay, sir.
Yeah, please stop live. Yeah.